If you like the story, you can support the author on Patreon. Link is in the description.
Chapter 102, The Spinal Clamp. Reeves walked Ryan out of the Drift Lab and toward the Elite Labs wing. The 5 labs had been organized into 2 work clusters based on their research mandates. Ryan had divided the work that way deliberately, putting groups with related deliverables in adjacent spaces so they could collaborate without daily oversight from him. Reeves pushed open the door of the first lab. This is the Connection Persistence and Stability team. The researchers inside were gathered around a central work table, examining several specialized components arranged across its surface. They looked up as the door opened. Several of them recognized Reeves and nodded. Then they noticed the second person in the doorway. Ryan had visited this lab approximately 0 times since the team had been recruited. The shock of his physical presence in their space was visible. A few of the researchers exchanged looks that contained equal parts surprise, embarrassment, and the nervous calculation of whether anyone was caught playing games on their workstation. 1. 6 months. The labs had been operating without their boss's direct oversight since the day they were brought online. That had been a calculated decision on Ryan's part. He'd assigned focused mandates with clear deliverables and trusted Reeves to keep the labs on track. The researchers had been free to work at their own pace, attend conferences, take extended lunches. Compared to their previous institutional environments, where principal investigators monitored every research move, the autonomy had felt like vacation. The autonomy had also felt like risk. The labs all knew what they were working on. Crimson Typhoon was the kind of project that produced careers. If they slacked, they were forfeiting their place in scientific history. The combination of light supervision and high-stakes work had created its own discipline. Nobody in the labs wanted to be the team that wasted a unique opportunity. Reeves saw the wide eyes around the room and grinned. "Today our base director and I would like to see your latest work. Show off what you've got." "Don't call me a director," Ryan said. "I don't actually have a title here." The room laughed. They all knew who the real authority was, regardless of titles. Ryan exchanged greetings with the team and walked over to the work table. "I heard you ran a test yesterday. How did it go?" A researcher named Frank Cabrera stepped forward to handle the briefing. Tall, mid-30s, the kind of confident but self-effacing posture that suggested he'd been the senior tech in the team before joining Prism Sciences. "Yesterday's test was successful, but Scrapper was too small a platform to fully validate the device. We didn't see anything anomalous, but we also couldn't push the system hard enough to find its limits." He picked up a long rectangular case from the table. The case had a transparent center panel, allowing the contents to be seen through it. Inside the case was an elongated metallic device. It looked like a stylized human spinal column, fabricated from segmented metal sections, each section connected to its neighbors by articulated joints. Each segment carried a small clamp on its forward face. "This is the spinal clamp," Cabrera said. "Formal name, total neural transmission plate. We call it the spinal clamp because that's what everyone calls it." 1. The clamp's purpose was specific. In a Jaeger-scale mech, the pilot needed to be physically locked into the cockpit position with high precision. The spinal clamp accomplished this while simultaneously serving as the primary neural signal conduit. It locked along the pilot's spine, fitted a sensor against each vertebra, and amplified the neural signals from the pilot's spinal column directly to the mech's control systems. 1. In small mechs like Scrapper, a sensor cap and chest harness were sufficient. The pilot's neural output was relatively low volume because the mech's command vocabulary was limited. In a Jaeger, the command vocabulary was orders of magnitude larger. The mech had thousands of articulating components, each requiring its own control signal, all needing to be processed simultaneously. The pilot's nervous system simply couldn't generate enough signal for that volume of data through scalp sensors alone. The spinal clamp solved this by interfacing directly with the central nervous system at the source, bypassing the noise and signal loss inherent in surface-level acquisition. Without the spinal clamp, 3 pilots could not control a Jaeger. With it, they could. "Pull up yesterday's data," Ryan said. "Let me see the test logs." Cabrera led him to a workstation and opened the relevant files. "We made minor modifications to Scrapper to support the spinal clamp interface. Scrapper's command vocabulary is small, so we couldn't actually stress test the clamp's bandwidth. But we did confirm that it transmits clean signals without interfering with the existing neural connection. Baseline functionality is verified. The bandwidth ceiling remains unknown." Ryan settled into the chair and began reading the logs. The pattern of his focus was familiar to anyone who'd worked with him, eyes scanning the screen at high speed, but his attention not exactly on the screen, occupying some larger conceptual space where the data became three-dimensional. A pen turned slowly between his fingers. The room went quiet. Reeves wandered over to the spinal clamp display case and examined the device with professional curiosity. He'd seen many of Ryan's technologies in this category by now. Each one had the same character, deceptively simple looking on the outside, terrifyingly sophisticated on the inside. The spinal clamp looked like a slightly fancy back brace. It was actually a precision neural interface that could decode signals from individual spinal segments at clinical resolution. The lab researchers exchanged glances. Each of them knew exactly how much work it had taken to translate Ryan's specifications into a working device. 2 months of pure analysis to even understand what Ryan had given them. The technical concepts had been pitched at the assumption that the readers were already at the frontier of their field. The labs had spent 8 weeks just learning the vocabulary required to interpret the design notes. Then they'd spent 6 more weeks building a working prototype with Patricia's manufacturing partners. And the entire concept had originated, fully formed, in Ryan's head. That was the part the labs had stopped pretending to find normal. Their team of 24 senior researchers had needed 3 months to fully understand a design that Ryan had produced as a single person. The asymmetry was disorienting. Most of them had quietly concluded that Ryan was operating on a different cognitive plane and stopped trying to understand the gap. Better to simply implement the work and accept the role of skilled hands building a vision that wasn't theirs. Ryan finished reading. This looks good. The bandwidth assumptions in the model match the observed transmission rates, within margin. There's nothing here that contradicts the intended operating envelope. He looked up. For full validation, we need to test the device on a system that can actually use the bandwidth. Scrapper's ceiling is too low. We'll have a better test platform soon. Cabrera asked the obvious question. Does that mean we test on the firefighting mech next? It has even fewer neural-controlled subsystems than Scrapper, so I'm not sure that helps. Ryan shook his head. Different platform. More appropriate scale. I'll loop you in when it's ready. For now, keep the device in a stable state and document any anomalies you observe during the holding period. He didn't elaborate. The test arm wasn't yet public knowledge among the lab teams, and Ryan preferred to keep information compartmentalized until each team needed to know. Cabrera nodded. He'd worked under classified research conditions before. He understood. I'll tell you when you need to know. Ryan thanked the team and headed out with Reeves toward the second lab. The OS and AI lab occupied the adjacent room. The reception was identical to the first lab, surprise at Ryan's physical presence, immediate composure recovery, and a brisk transition to demonstration. The principal investigator, a woman named Clara Morales, took the lead on the briefing. OS work is at 20% completion. The full operating system architecture is significantly more complex than we initially scoped. We're working through it methodically, but it'll be a longer timeline. That's expected. Don't rush it. AI work is much closer to completion. We're at near 100% for core functionality. Ready for a system test. Morales walked Ryan through the AI's capabilities. The mech AI's role was supportive, monitoring system status, alerting pilots to operational anomalies, automating routine functions, and adapting mech parameters to match individual pilot characteristics. When the mech took damage, the AI would automatically run diagnostic protocols and report damage extent. When the pilot was distracted, the AI would handle peripheral situational awareness. When 2 pilots in the drift had different control preferences, the AI would mediate parameter adjustments to harmonize their inputs. None of these tasks were individually difficult. The complexity came from coordinating them across thousands of subsystems in real time, integrating with the pilot's neural inputs without introducing latency, and ensuring the AI's behavior aligned with the pilot's intentions rather than overriding them. The AI was, fundamentally, a co-pilot rather than a controller. It made the mech easier to operate by handling cognitive overhead, freeing the pilots to focus on tactical decisions. Ready for ground test on the firefighting mech? Ryan asked. Yes. We have a test plan ready to go. We can run validation as soon as Marsh's team is available. Coordinate with them directly. I want results within 2 weeks. Understood. Ryan thanked the team again. He and Reeves left the lab and walked the corridor back toward the main building. 2 of the 5 labs were on track. 3 more to check. And the test arm waiting in the storm bay, growing more real every day as the technical crew assembled it. The pieces continued to converge. Drawing manga/comic in Marvel. Chapter 103, Assembly complete. The technical crew worked around the clock for the next 2 weeks. Storm Bay's lights stayed on day and night. Heavy machinery operated continuously. Welders, machinists, hydraulics technicians, and electrical engineers moved across the chamber in coordinated shifts, executing Ryan's master assembly diagrams with precision. Ryan visited every few days to check progress, but the crew was professional and didn't need supervision. The diagrams were exhaustive. The components were precisely fabricated. The work had a clear endpoint. Once Ryan confirmed each phase was on schedule, he returned to his quarters and continued his own research. Crimson Typhoon's damper system was complete. He'd absorbed the architecture down to the last subcomponent. The full system was now in his head, every valve and cross-link mapped to a function, ready to be physically built when the time came. His current focus was the underwater seal system. Crimson Typhoon was designed for deep ocean combat. The Pacific Rim universe's final battle had originally been planned with 4 Jaegers, 3 providing cover while 1 delivered a payload, all operating at depths of 7,000 meters. At that depth, water pressure reached 700 kilograms per square centimeter. In SI units, every square meter of mech surface had to withstand 7,000 metric tons of compression. Sealing a structure against that kind of pressure was difficult enough when the structure didn't move. For a static deep-sea vehicle, conventional rigid seals worked. Submersibles and undersea research stations relied primarily on static sealing. But a Jaeger wasn't a static vehicle. It walked. It punched. It opened weapon ports. Every joint in the body was a potential pressure failure point. Every articulating component had to be sealed without restricting motion. The technical name for the engineering challenge was dynamic sealing under high-pressure conditions. The solution Crimson Typhoon used was a hybrid, static seals for the non-articulating surfaces, dynamic seals at every joint, and a tertiary backup system for the highest stress junctions. The dynamic seals used multi-layered elastomer rings that compressed proportionally to external pressure, maintaining their seal integrity across the operational depth range. The system, like every Crimson Typhoon technology, would be a major contribution to multiple industries beyond mech engineering. Submarine design, deep-sea oil and gas, underwater pipeline construction, marine research. Anywhere requiring high-pressure dynamic sealing, Crimson Typhoon's solution was a step-change improvement over the existing state-of-the-art. By the time Ryan had absorbed the seal system, the technical crew had finished assembly. Patricia called him with the update. Storm Bay is ready. They've finished. Ryan walked to Storm Bay alone, opened the personnel door inset into the main panel, and stepped through. He looked up. The first thing he saw was a red mountain. A mountain of red flame. The fully assembled arm dominated Storm Bay. It lay horizontal on the chamber floor, suspended slightly on its assembly cradles, stretching nearly the full 50-meter length of the bay. The titanium armor plates had been attached, painted in the red and gold scheme of Crimson Typhoon's signature appearance. Under the chamber's bright lights, the surface looked like burning metal, like flames frozen mid-motion. Beneath the visible armor, the structural housing showed through at the unarmored sections. The internal architecture was visible in the shoulder joint area, where the diesel engines and hydraulic conduits and fiber-optic neural pathways were stacked like the muscle striations of a colossal arm. The upper arm was massive. Tiered diesel engines stacked along its outer flank, mimicking the deltoid muscle of a human arm. The engines weren't decorative, they provided the prime mover power for the arm's high-torque movements, with hydraulic actuators converting the engine output into joint motion. The forearm was thinner relative to the upper arm, optimized for speed rather than raw strength. The streamlined shape echoed a human forearm's proportions while housing the wrist articulation system and the retractable saw blades. The hand was a 4-fingered claw configuration, oversized relative to the rest of the arm but proportioned to deliver crushing grip and slashing impact. The fingers ended in talon points, the interfaces of the palm covered in armor. Indicator lights mounted along the arm's length stood out from the surface, each one a cylinder approximately half a meter tall. The lights would illuminate when the corresponding subsystem was active, providing visual confirmation of operational status. The arm was magnificent. 2. Ryan walked over to the upper arm section and rapped his knuckles against the titanium armor. The plate didn't even register the impact. He'd never built anything this dense. Scrapper's armor was thin sheet metal by comparison. He turned to the lead technician. Verify with the team that everything matches the master assembly diagrams. Any deviations, document them now. The technician nodded. The crew did a final walkthrough, comparing the assembled arm against the diagrams, point by point. After 30 minutes, they confirmed, every component installed per spec, no deviations. The technician pointed up at the gantry crane mounted on the chamber's ceiling. Should we hoist it now? The original plan was to suspend the arm from the gantry for testing, allowing it to move freely without bearing the weight on its mounts. Ryan shook his head. Add fuel first. Run the engines. I want to see it power up before we lift it. Understood. The crew connected fuel lines to the arm's diesel tanks and began filling. They added a small quantity, just enough for a startup test, then disconnected the lines. The technician lead found the manual ignition button on the upper arm section and pressed it. A series of mechanical clicks. Then the diesel engines turned over, caught, and started. The sound was deep and steady. Multiple engines firing in harmony, their exhaust ducted through internal channels to vents in the armor. The arm's indicator lights began illuminating one by one, each light coming up red as its subsystem reported nominal status. Within 30 seconds, every indicator was lit. The arm was running. Ryan applauded slowly. The crew followed. Good. Hoist it now. And get me the elite labs. They need to see this. He pulled out his phone and called Reeves. Reeves and the lab team arrived within 10 minutes. They came in through the back entrance, and the first one through the door, Reeves himself, stopped dead in the doorway. The rest of the team piled up behind him, unable to enter past his frozen frame. Reeves. Someone said behind him. He didn't answer. He was looking up. After several seconds, Reeves moved aside and let the others in. Their reactions cascaded through the same pattern: doorway, stop, look up, shock, slow walk forward. What is this? Holy Mother of! How is this big? How can this be a single arm? It looks like the hand of God. The team had been working on technologies for a Jaeger scale system for months. They'd seen the design specifications. They'd known the physical scale was substantial. None of that had prepared them for actually standing in a chamber with a Jaeger arm hanging from a gantry crane 4 meters above their heads. Ryan walked around from the other side of the arm to greet them. Frank Cabrera, who had built the spinal clamp, was the first to find his voice. This isn't an arm of an actual mech, is it? The unspoken arithmetic was visible on every face. The arm in front of them was several times Scrapper's full body. If it was just one arm of a complete mech, then the mech itself. The mech itself would be enormous. Not Scrapper large. Not even Scrapper times 5. Something on a different scale entirely. The labs had been told they were working on a major project. They hadn't been told what kind of major. The implications were now becoming visible. Ryan didn't bother dissembling. Yes. This is the right arm of a Jaeger-class mech currently in design. Code name for the arm is Storm. Your job is to use your accumulated work to operate it. We test it as soon as the supporting systems are integrated. 3. The team members looked at each other. They looked at the arm. They looked at Ryan. The realization that their research had been preparation for the construction of a Jaeger spread through the room in real time. The room's mood shifted from awe to something more complicated. Awe was still present. But it was now mixed with the adrenaline of personal stakes. They weren't observers of a project anymore. They were participants in something that, if successful, would reshape the technological landscape of multiple industries. This was the kind of work that defined careers. The kind of work that ended up in textbooks. The kind of work that justified the past 6 months of high-stakes, low-supervision research. Cabrera's expression cycled through several emotional states before settling on something that looked like determination. When do we start? 2 weeks. Get your systems ready for arm-scale integration testing. The hoist motors hummed. The technical crew finished securing the cables. Storm rose slowly off the floor, suspended 4 meters in the air, hanging in the chamber like a sword over the heads of every person watching. The team caught their breath as the arm passed the 2-meter mark, then the 3-meter mark. The cables held. The arm reached its testing position and stopped, gently swaying. Storm was airborne. Storm was alive. The next test was real system integration. 3 pilots in the drift apparatus, the spinal clamp installed, the AI online, all routing their combined signals through the 70 tons of suspended Jaeger arm. If it worked, the Crimson Typhoon program would be one milestone away from full construction. If it didn't work, they'd need to figure out why and try again. Either way, the answer was coming in 2 weeks. Drawing manga/comic in Marvel. Chapter 103, New FIC. Tom Goes to Hogwarts 3. Reborn in America, trained at Ilvermorny, and handed a system 7 years late, Susanna Sunahale spent a decade wandering the world as the Wizarding World's best-selling travel author. Her reward? Tom. Yes, that Tom. The cat who cooks 5-star meals, folds cabins into luggage, and fears exactly one potion's master. Then Hogwarts comes calling with the one job no sane witch takes, the cursed defense against the dark arts post. Suna throws the letter in the trash. The system fishes it back out. Fine. She'll teach her way. And Hogwarts will never be the same. No romance. Chaotic teaching, found family, and one long-suffering cat. Drawing manga/comic in Marvel. Chapter 104, The Test, Part 1. Storm Bay's construction was the easy part. The remaining work was software. Operating a mech, or even a single arm, required more than the hardware being physically functional. The arm needed an operating system. Not Crimson Typhoon's eventual full operating system, but a purpose-built test OS designed to interface the spinal clamp signals with the arm's hydraulic and pneumatic systems. The test OS needed to be precise enough to translate 3 pilot neural input into coordinated arm movement, while flexible enough to log diagnostics across every actuator for post-test analysis. The manufacturers who'd built Storm's hardware were out of scope for this work. Their contract had been to deliver the physical arm. The software was Prism Science's problem. Ryan camped at the 2 relevant labs and stripped to the work. His arrival accelerated the lab's progress to absurd levels. Researchers who'd been wrestling with a difficult problem for days would describe the issue to Ryan, and within minutes Ryan would offer an approach that resolved it. Some of the problems Ryan answered without looking up from his notebook, by analogy from work he'd done in unrelated domains. Others he engaged with more directly, sketching out the solution at the whiteboard while the team copied notes. Within a week, the long-stalled operating system had advanced significantly toward completion. The dedicated ARM test OS, which hadn't existed when Ryan started, went from zero to production-ready in the same week. The researchers spent the entire week in a state of professional disorientation. The pace was unprecedented. People started joking that time accelerated in Ryan's immediate vicinity, that minute-long trips to the bathroom returned to find that their projects had advanced past the point of comprehension. The feeling was familiar to anyone who'd ever bent over to retrieve a dropped pen during a math lecture, looked back up, and realized the professor had moved through 6 steps of derivation in the interim. At the end of the week, Ryan stood up from the workstation, stretched, and announced that the preparation work was complete. The ARM test would be conducted in the coming days. The labs were spent. They'd run a marathon at sprint pace for a week. None of them felt they'd done meaningful work because Ryan had been driving every step. They'd been note-takers more than researchers. Several of them privately admitted to friends that they were exhausted in a way they hadn't experienced since graduate school finals week. The triplet pilots were notified of the test date and asked to report to Storm Bay. Jake, Marcus, and Dean walked into the chamber together and stopped at the doorway. Storm hung 4 meters above the floor, suspended from the gantry crane. The red and gold titanium armor caught the chamber's overhead lights and reflected them back in long bands of flame. The arm's articulated joints showed through the unarmored gaps. Every line of the machine spoke to mass and intention. "What is that thing?" Jake said, with the careful tone of someone who was hoping he was wrong about the obvious answer. "That," Ryan said, walking up behind them, "is what you're going to drive today." The triplets exchanged looks. None of them spoke for several seconds. Then Dean, the youngest brother, asked the question. "We're driving an arm that's bigger than a city bus." "Yes." "How?" "It doesn't have a cockpit." The brothers looked at the suspended arm again. They'd grown comfortable with Scrapper. They'd been operating mechs, admittedly Scrapper-sized mechs, for months. Their mental model was, pilot climbs into cockpit, pilot connects neural link, pilot operates mech. This arm had no cockpit. Where was the pilot supposed to sit? "Different setup," Ryan said. "The arm is incomplete. It doesn't have a body for you to climb inside. You'll be controlling it externally." He gestured toward a side door. "Follow me. We have a control room." The control room was elevated above Storm Bay's main floor, positioned at the rear corner of the chamber, accessed via a staircase. The room's front wall was glass, providing a clear view of the suspended arm and the bay below. The interior had been reconfigured for the test. Cabling thick as a forearm ran from a central platform in the room's middle, exited through a conduit in the wall, and connected to Storm's shoulder joint. The platform itself was familiar in form. It resembled Scrapper's pilot platform, redesigned for the present application. The most notable difference was that the platform had no visible cockpit equipment, no neural link harness in evidence. "Ryan, the neural link platform is ready," Frank Cabrera said. He looked exhausted but excited, the kind of expression that came from running on caffeine and adrenaline. "Operating system installed and running. No technical issues on the ARM hardware," the other lab's lead reported. "Let's start a trial," Ryan said. He turned to the triplets. "Which of you wants the first ride?" Jake stepped forward. "I'll go." Ryan gave him an OK sign and called over the technical crew. "Equipment up." The crew brought out several large cases. The first case contained a black bodysuit. The material was similar to Scrapper's pilot vest, but the new garment was a full-body unitard with neural sensors distributed throughout the inner surface. The suit covered everything except the head, like a wetsuit for an extremely high-stakes diving expedition. Jake stripped down and pulled on the bodysuit. Sensors made contact across his torso, arms, and legs. The second case contained a series of red armor plates, segmented into upper torso, mid-torso, lower torso, shoulder, and limb sections. The crew began attaching the plates to Jake's bodysuit, securing each section with quick-release fasteners that locked into precision-machined receivers. The armor wasn't decorative. It served as the physical mounting structure for the spinal clamp and helmet, distributing the load and isolating Jake's body from any electrical or mechanical feedback. By the time the armor was fully attached, Jake looked like the protagonist of a high-budget science fiction film. The team in the control room collectively did a double take. "The armor is so cool. Get me one for my birthday." "How do I get one of these?" Jake test flexed his arms and legs. The armor was rigid where it needed to be, articulated where it needed to move. He could walk, turn, and gesture without restriction. Heavy combat motions might be limited, but the armor wasn't going to interfere with normal use. "Hold still," the crew chief said. He approached Jake from behind. The team opened a sealed case and extracted the spinal clamp. The armor's back section had a vertically oriented receiver groove machined into it, sized to accept the clamp. The crew aligned the spinal clamp with the receiver, lowered it into position, and pressed it home. Click! The clamp's internal mechanism engaged automatically, distributing its individual segment locks across the matching positions of the receiver. The indicator lights along the clamp's length illuminated in sequence from base to crown, each segment registering successful contact. Jake felt the clamp engage. He didn't move. He'd been warned not to. Ryan picked up the helmet from a table and presented it to Jake. The helmet was red, designed to match the armor. The front faceplate carried a stylized five-pointed star emblem. The central inverted triangle of the star formed a double-layered transparent visor. The bottom 2 points of the star housed communication equipment. The top point recessed inward. 4. A yellow gel-like substance occupied the gap between the 2 layers of the visor. The substance had a specific function. Jake didn't know what yet. The helmet's sides featured several connection ports, oxygen feed, data cables, telemetry ports. "Put it on." 1. Jake lifted the helmet over his head and lowered it into position. A soft click as the helmet's mounting points engaged with the armor's neck collar. The yellow gel inside the visor began draining. It withdrew through the helmet's interior systems, leaving the visor clear and transparent within seconds. The mechanism behind it was apparently a data transfer medium. The gel had served as the connection conduit between the helmet's external interfaces and the internal display systems. Once the data link was established, the gel was no longer needed for transmission. "Don't worry about it," Ryan said. "The gel is just a transfer medium." Jake nodded, breath fogging the inside of the visor briefly before the helmet's climate control compensated. Ryan gestured toward the platform. "Step up. We're starting." Drawing manga/comic in Marvel. Chapter 105, The Test, Part 2. Jake stepped onto the platform. The technical crew moved into position. They guided him onto the platform's support frame and secured him from behind, using a precision-fitted steel plate that connected the support frame to the back of his armor. The plate also concealed the exposed spinal clamp, providing both mechanical retention and protection against accidental contact. Oxygen lines snaked out from a wall-mounted manifold. The crew connected them to the helmet's intake ports and switched on the air supply. A separate set of cables connected the helmet's data ports to the control system. The helmet's internal radio activated with a soft tone. "Better," Jake said, breathing through the new air supply. The helmet was airtight by design. Without active oxygen feed, breathing would have been forced through the small intake ports on the helmet's sides, restrictive at best. Ryan stood back and looked at the suited pilot. The armor and helmet combination was striking but incomplete. In the original Pacific Rim film design, the pilot suit included a full life support system that monitored vital signs, regulated body temperature, and provided emergency medical support. The version Jake was wearing was a stripped-down test prototype. Only the helmet and spinal clamp were fully functional. The bodysuit's sensors were limited to the right arm subset, since today's test only needed right arm input data. The full version would come later. For now, the simplified rig was sufficient. The crew chief completed the pre-test checklist, walked through the operations manual to verify every step had been executed, and reported readiness. Ryan looked at Jake. Jake gave a thumbs up through the helmet's reinforced glove. "Begin," Ryan said. Level 1 control mode. At the monitoring station, Cabrera depressed the neural connection activation. Jake felt the connection establish. His subjective experience, like being submerged in viscous fluid. The pressure was significantly higher than what he'd experienced operating Scrapper, even at maximum load. Ryan walked to Cabrera's station and checked the readings. The display indicated a neural load of 15 units. The unit scale had been calibrated against Scrapper's connection profile, where standard operation registered as 10 units. Jake was currently experiencing 1.5 times Scrapper's load. "How is it?" Ryan asked. Jake's response came through the room's speakers, transmitted from the helmet's radio. "Manageable. Some pressure. Not severe. Try moving your right index finger." Jake complied. The diesel engines outside cycled. The right index finger of Storm's hand extended, then flexed, then returned to neutral. The motion was clean and synchronized to Jake's input. The control room broke into applause. "It moved. It actually worked. This is the first mech I've ever worked on." The researchers who weren't assigned to active monitoring duty crowded the observation window, watching Storm's slow finger movements with the kind of attentive joy that comes from seeing a long-built theory survive contact with reality. The arm responded to Jake's intentions. Their accumulated work had translated into physical motion. Even the researchers who recognized that most of the technical credit belonged to Ryan still felt the satisfaction of having contributed. They had built the implementation. The vision had been Ryan's, but the execution required hundreds of hands. Ryan checked the data feed. Every metric within normal range. Spinal clamp transmission clean. Operating system processing nominal. Hydraulic response within latency targets. Prepare for level 2 control. Adding next finger. The control modes had been designed in escalating stages. Level 1 activated neural control of one finger. Each subsequent level activated control of an additional component, fingers, then wrist, then elbow, then shoulder, then weapon systems. At higher levels, the pilot would be managing significantly more sensor input and control output simultaneously, increasing the neural load proportionally. Jake had operated mechs before. The first few levels were familiar territory. He adapted to the increased load with practiced ease. Within 10 minutes, he was at level 4, controlling all 4 fingers of Storm's hand simultaneously. "How is it now?" Jake's eyes were closed inside the helmet, his concentration focused. "Pressure is significant. Like my head submerged in wet concrete. Slight disorientation. I can hold it." Ryan checked the display. 54 neural load units. Still far below the spinal clamp's theoretical ceiling, but well past Scrapper's operating range. Jake's reported symptoms, the wet concrete feeling, the disorientation, matched the predicted neural fatigue profile. "Try operating the entire hand." Acknowledged. Jake committed his attention to the action and stopped speaking. His right hand flexed and unflexed slowly. Storm's hand mirrored each motion, the massive 4-fingered claw closing and opening above the base floor. A few researchers requested permission to leave the control room. They walked down the staircase and crossed the bay floor to stand directly beneath Storm. Up close, the suspended arm was different. From the control room, it was machinery. From below, it was a presence. The fingers moved overhead, each one larger than a person, painted in red flame, sliding through positions that took fractions of a second to execute but felt much slower because the size of the object lent them an impossible weight. "This is overwhelming," one of the researchers muttered. The technical crew, who had been hands-on with the arm during assembly, were quietly leaning against the bay walls and watching. Several had their hands on their hips in the universal posture of engineers admiring their own work. A few were silent. A few exchanged the kind of glances that don't need words to communicate that something significant was happening. If facility security regulations hadn't existed, every member of the team would have been filming this on their phones. The security regulations did exist. But Ryan, watching from above, pulled out his phone and started filming the test arm's movements. The remaining researchers in the control room noticed. For a moment, they didn't know what to do. The man whose job it was to maintain operational security had just started recording an active classified test. The contradiction was confusing on a conceptual level. Ryan was the one who set the security policies. He was also the one violating them. A few of the researchers exchanged glances. One started to raise an objection. The door to the control room opened. Patricia walked in. The researcher's eyes turned to her with hope. Patricia would handle this. Patricia would make sure protocol was followed. Patricia saw Ryan filming. She paused. She shook her head once with mild exasperation. Then she walked to the observation window and stood watching Storm operate. She did not stop Ryan from filming. The researchers looked at each other again. The conclusion was unmistakable. Ryan had some kind of exemption that no one else had. Or Ryan didn't care about the rules. Or Ryan was the rules. Either way, the situation clarified itself, nobody was going to stop him. Ryan recorded for a few more seconds and put the phone away. He turned to Patricia. "What brings you?" "Just checking in on the test." "How's it going?" Patricia's eyes were on Storm. She was processing the test result with her own private surprise. The upper leadership had been intensely interested in this experiment. Based on what she was seeing, it had apparently succeeded. Which made it, she thought, almost too easy. "It's going fine," Ryan said. "I'm always fine." He turned back to the monitoring station and asked Jake for another status check. "Still here?" Jake's voice came back a moment late. The delay registered with Ryan. Jake's reaction time had increased. The cognitive load was creeping past his adaptation envelope. Continuing would risk pushing him into actual neural overload, which would do no good for the test data or the pilot's longer-term tolerance. "Come down. We'll cycle in the next pilot." Cabrera disconnected the link. The technical crew moved in immediately, helping Jake out of the helmet and armor. The crew chief checked Jake's vitals while another technician readied the equipment for the next pilot. The Petersons' lead brother stepped forward. The cycle began again. The test continued for 3 more rotations, each pilot taking a turn through the control levels. The data was consistent across all 3 triplet sets. Storm responded to single pilot input cleanly at every level up to 4. Above that, the neural load began straining individual pilots within minutes. That was the expected result. A Jaeger-class arm wasn't meant to be operated by a single pilot. It was meant to be operated by 3. The next phase of testing would require all 3 brothers connected simultaneously through the drift system, sharing the neural load and routing it collectively through Storm. That phase was scheduled for the following week. By the end of the day, Storm Bay's overhead lights were dimmed, the gantry crane was locked in position, and the Jaeger arm hung silent in the darkened chamber. The first phase of the test was complete. The arm worked. The platform worked. The spinal clamp worked. The operating system worked. The AI integration was pending but on track. The hardest test was still to come. But the foundation was solid. Author: "Hi guys, it will be helpful if you guys can give some power stones to Tom Goes to Hogwarts, my new FIC, as it's a new FIC. I know you guys will help me, so I will upload an extra chapter today." 1. Drawing manga/comic in Marvel. Chapter 106, 100%. Extra chapter. By nightfall, all 9 pilots had cycled through the platform. Each of the 3 triplet sets had taken multiple turns. The test ran until Storm's fuel tanks were empty. The neural load tolerance across the 9 pilots was consistent. All of them peaked around 50 units of cognitive load before symptoms of pressure overload began appearing. That ceiling was expected and was projected to expand with training. The pilot's neural systems would adapt to the increased load the way muscles adapted to weight training, given progressive exposure. "That's it for today," Ryan said as the last pilot was helped off the platform. The technical crew was already removing the helmet and armor. He gathered the test data into a portable drive and headed for the control room door. "I'm heading back. Good work today. See you tomorrow." The 2 labs members waved him out. Ryan stepped out of Dome Base into the cool coastal evening. The moon was bright overhead. He stretched and considered the cafeteria for dinner. He opened his system panel out of habit. Project 3, 0%. He stopped walking. 0%. That wasn't right. The progress bar had been hovering around 90% the last time he'd checked, days ago. It should be approaching completion, not at 0. Then his brain processed what he was actually seeing. The progress wasn't at 0. There was a new project showing 0%. Which meant the previous project was complete. He opened the completed projects list. 2 entries now, where previously there had been 1. Scrapper at the top. And beneath it. Crimson Typhoon. 100%. Ryan exhaled. The Triton 1 launch had pushed the final summon points across the finish line. 800 million people heard the words Triton 1 or Mercer during the launch cycle. The cumulative attention had unlocked the remaining Crimson Typhoon technology. He opened the completed project's technology tree and scanned the contents. Every system. Every subsystem. Every component. Liquid neural connection. The Midnight 9 toroidal power core. The Trinity Horizon operating system. The underwater seal system. The damper architecture. Plasma cannon, already in production. Spinal clamp, already prototyped. The drift system. The hull structure. The control surfaces. The exterior armor specifications. All of it. Available to read. Available to build. The most demanding technologies remaining were the toroidal power core and the operating system. Everything else was either already understood or close enough that Ryan could absorb it in days. Crimson Typhoon was now technologically possible. Ryan walked to the cafeteria, picked up takeout, and headed back to his quarters. He had a month of intensive study ahead of him. The Midnight 9 toroidal power core was the heart of Crimson Typhoon's energy system. The core's design challenge could be summarized in one sentence: how do you burn diesel as efficiently as physically possible? Crimson Typhoon used diesel propulsion. Compared to the nuclear-powered variants in the source material's later generations, diesel had a major endurance disadvantage. Crimson Typhoon couldn't carry enough fuel to operate indefinitely. Every gram of efficiency gained in the combustion process translated directly into additional combat time. The Midnight 9 was the engineering answer to that problem. A toroidal combustion chamber designed for maximum thermodynamic efficiency. Multi-stage fuel atomization. Plasma-assisted ignition, using the same plasma generation technology that powered the cannon. Active waste heat recovery feeding back into auxiliary systems. The combat endurance specification was 8 hours of sustained operation on a full fuel load. For a kaiju engagement, 8 hours was more than sufficient. No Jaeger pilot would last 8 continuous combat hours under any circumstances. The mech could keep going long after the pilots couldn't. Ryan dove into the specifications. The operating system was next. He'd already started this work through the elite labs. The system architecture was, to him, the most directly interpretable of all the Crimson Typhoon technologies. Software was about logic and data flow. With complete reference documents, software was, in Ryan's framing, like solving a maze with the map provided. What had taken the elite labs months to begin to implement, Ryan could understand in days. He ate dinner while reading. He didn't notice that the kitchen had used sugar in the tomato scramble. Time accelerated. Ryan disappeared into the technology tree. He stopped going to Storm Bay. He took meals delivered to his quarters. He slept when his body demanded it and worked the rest of the time. His occasional phone calls home were his only social interaction. The elite labs, which had been briefly delighted to have Ryan's daily presence accelerating their work, found themselves abandoned again. Cabrera's team and Morales' team went back to their previous mode of independent work, supervised by Reeves, continuing the research mandates they'd been operating under. They also worked with the pilot trio on neural load training, building up the pilot's tolerance for higher cognitive demands. The cycle of unsupervised work was, by this point, familiar to the labs. When focused, Ryan worked with the efficiency of a tunneling machine. A month passed before he came up for air. He stretched, blinked at the calendar on his laptop screen, and registered the date. A month. He'd been studying for a month. The pace was insane. The fact that he'd absorbed the entire Crimson Typhoon technology tree in a single month wasn't a feat anyone outside his head could properly evaluate. The technology tree contained thousands of distinct subsystems. Engineers working in normal conditions would have spent careers understanding any one of them in depth. But the system documentation was structured for fast comprehension. The pieces were designed to fit together. The interdependencies were mapped and indexed. The work was less research and more memorization with comprehension. Still, a month. He looked at the documentation he'd organized on his hard drive. The original Crimson Typhoon proposal he'd submitted to the chairman months ago had been a high-level technical outline. The version he had now was full construction documentation. Every component dimensioned. Every fastener specified. Every welding tolerance documented. Every alloy composition characterized. Construction-ready blueprints. The kind of documentation that a manufacturing organization could read and start fabricating from immediately. No interpretive work needed. No engineering judgment calls. He packaged the documentation onto secure drives, sealed them in a transport case, and walked to Patricia's office. Patricia was at her computer when Ryan knocked. She looked up. Her expression said multiple things simultaneously: relief, exasperation, and the resigned acceptance of someone whose job had grown beyond her original contract. "You've finally come out of your room." Ryan rolled his eyes. "I followed proper sleep schedules. The probability of sudden death from overwork was statistically minimal." Patricia laughed without much humor. The point landed because it was true and also because she'd spent the past month worried about exactly that probability. She'd started her career as a finance manager at Aegis Industrial. A modest portfolio, low eight-figure budget oversight, occasional administrative duties. 6 months ago, she'd been assigned to Ryan's project as the financial controller for a junior research program. 6 months later, she was operating a multi-hundred-person research base, managing budgets in the hundreds of millions of dollars, and was effectively the senior caretaker for a teenager who, depending on the day, was either changing the future of humanity or skipping meals to read documents. She wasn't sure how she'd ended up in this role. She also wasn't sure she could leave it. The work was too important and the trust she'd built was too valuable. Replacing her with someone new would cost the operation months of stability. She accepted the situation. She also kept a discreet medical team on 24-hour standby for Ryan, just in case. Ryan placed the case on her desk. "The documents inside are ready for delivery. Civilian applications go to me, defense applications go to your organization, as usual." Patricia heard the rattle of hard drives. She lifted the case lid and looked at the contents. Multiple sealed drives. The case was heavier than usual. "That much? That much? Anything you want me to tell them?" Ryan shook his head. "They'll understand when they see what's in there." The case rode in a secure courier vehicle to Aegis Industrial's main facility the following morning. The documents reached the chairman's office before lunch. By that evening, the chairman had reviewed the executive summary of the documentation. By the next morning, he'd seen enough of the technical drawings to confirm that Ryan had delivered construction-ready blueprints for the most ambitious engineering project in history. The chairman picked up his red phone. 4. Drawing manga/comic in Marvel. Chapter 107, The Firefighting Problem. Patricia left in a helicopter. Ryan heard the rotor wash from inside Dome Base and looked up at the ceiling reflexively. Then he remembered, the helicopter was now under the engineering crew's control. They were using it to ferry materials for the new dormitory construction. The aircraft hadn't been Ryan's personal transport for some time. He opened the system panel again. Project 3, 0%. No information about what Project 3 actually was. The system only revealed project identity when progress crossed 10%. Below that threshold, the project remained anonymous. 1. This was the system's quirk. Project 2, Crimson Typhoon, had stayed unidentified for weeks while Ryan was working on the scrapper live streams. The progress had crawled forward at the rate of a snail moving uphill, advancing only through whatever organic attention the system was harvesting from Ryan's existing public footprint. The faster Ryan generated public attention, the faster the project unlocked. Project 3's identity would reveal itself only when enough summon points had accumulated to push the progress past 10%. The Triton 1 launch had pumped enormous summon points into the system, but most of those had gone toward finalizing Crimson Typhoon. The new project was starting from scratch. Ryan set the question aside. There was no point in speculating. The information would arrive when it arrived. He walked through Dome Base's corridor, his footsteps clanging on the steel grate floor. He was heading toward the firefighting mech bay to check in on Kyle's team. Kyle wasn't in Scrapper's bay. A handful of technicians were inside doing training rotations for new hires. The technical workforce had been growing recently as Dome Base ramped up. Ryan crossed to the adjacent bay. Kyle was at his laptop, both hands in his hair, completely absorbed in some problem on his screen. Professor Marsh stood beneath the firefighting mech with several students, deep in discussion. Today was a scheduled rest day, but Marsh was on site anyway, the only professor present. Marsh. How's the mobility issue from the last test? Marsh sent the students off and turned to Ryan. The students drifted toward the corner of the bay to grab coffee, leaving the two of them alone. Not serious. We swapped the failed structural component with a higher grade alloy and ran a second mobility test. The flat terrain performance is now confirmed to spec. Next phase, we want the engineering crew to excavate a simulated mountain terrain pit so we can verify the mech's mobility on uneven ground. As long as it's not a fundamental problem. It's not. The big problems are solved. The small problems remain. What kind of small problems? Marsh raised his hands. Let me walk you through them. Maybe you'll see an angle I haven't. We've been designing a secondary suppression system for the mech, trying to allow it to use different firefighting media depending on the fire type. We're also looking to refine the primary water system. The current approach, return to base, swap tanks, redeploy, feels inefficient. We want the mech to stay on the front line longer. Ryan nodded. He'd already considered this. The current design had the mech walking back to the supply point every 6 minutes, when fully discharging at maximum rate, or every several hours, under typical usage. Either way, the mech spent transit time outside the fire zone instead of fighting fires. Compared to a firefighting helicopter carrying a few tons of water, the mech's 26-ton load was an improvement. Compared to staying continuously deployed, it wasn't. The logistical overhead was also problematic. The supply organization needed to manufacture and ship enough water tanks to support continuous mech operations. Tanks had to be heavy-duty enough to survive rough handling but light enough to be transportable. The whole system was a logistical headache. The mech's fireproof advantage was being underutilized. The vehicle could operate in environments that no human firefighter could survive. It shouldn't be retreating from those environments to swap tanks. It should be staying there. Ryan tapped his chin. Different angle. What if the mech doesn't carry its own water? Marsh paused. Meaning? We attach a long hose to the back of the mech, or another accessible mounting point. When the mech deploys to the fire, it carries the hose with it. The pumper truck stays at the staging area, well outside the fire's heat envelope, and supplies water to the mech through the hose. 1. Ryan tapped the leg of the firefighting mech. The titanium and composite housing rang dully. The mech doesn't carry full tanks for transit. The mech's deployment weight is lighter, which means faster travel time and reduced fuel consumption. When the mech reaches the fire, it connects to the hose system from the staging area and operates with effectively unlimited water supply, as long as the pumper trucks can keep up. Marsh's eyes brightened. He picked up the idea and ran with it. And while the mech is moving toward the fire, the pumper can pre-fill the onboard reserves through the hose. By the time the mech reaches the fire line, its internal tanks are topped off. The mech isn't waiting for the supply chain. The supply chain is delivering water as the mech advances. So it becomes an ongoing flow problem instead of a discrete delivery problem. Right. The mech can keep firing as long as the pumpers can keep up. The pumpers can refill from rivers, water trucks, hydrants. The mech's water capacity becomes effectively unlimited. Marsh started pacing in the slow circles of a man who had just realized he was holding the answer to a problem he'd been chewing on for weeks. He was running the implications in real time. This changes the logistics completely. The supply trucks no longer carry pre-filled tanks. The supply trucks become the source. Standard pumper trucks with minor adaptation can handle the role. We can drop the dedicated tank fleet entirely. And the mech's mass during transit goes down significantly. Faster deployment. Better fuel economy. Better response times. Ryan nodded. This was indeed his intent. The implementation details, hose abrasion, pressure management, attachment point design, were solvable engineering problems that wouldn't require breakthrough thinking. High wear surfaces on the hose would need abrasion-resistant materials. The connection point on the mech would need a high-pressure quick-release fitting. The pumper trucks would need pumping capacity matched to the mech's discharge rate. None of these were research-level problems. Marsh was already thinking through the rest of the design changes. This is huge. With the supply problem solved, the mech's combat envelope expands dramatically. It can stay in the fire zone indefinitely. It can sustain water discharge for hours. It can support multiple deployments in a single operation. The mech's other capabilities were genuine, too. Fire-resistant exterior, with high silica thermal protection rated for sustained operation at extreme temperatures. Heat barriers and water spray cooling on the mech's exterior. The 4-leg platform mode for stability in active fire zones. The leg-mounted circular saws for clearing debris and creating fire breaks. The 26-ton internal water reserve for high-rate suppression bursts. The 85-meter water cannon range. The carrying capacity of 9 human firefighters in addition to the pilot. With unlimited water supply, all of those capabilities became dramatically more useful. Marsh wanted to go straight to the drafting table and redesign the mech around the new supply approach. He had to consciously stop himself. Ryan was here. Ryan was rare. Marsh had several more questions queued up. He wasn't going to waste the opportunity. The discussion continued for another hour. Meanwhile, Patricia had landed at the Aegis Industrial Regional Office and uploaded the blueprints into the secure transfer system. The portable drives were sealed in a courier package and shipped to the company's main headquarters via Priority Express. The data arrived in Aegis's secure document repository minutes after the upload. As had become standard practice for any deliverable from Prism Sciences, an expert review panel was convened to evaluate the contents. The panel members assembled with the practiced anticipation of veterans. They'd reviewed Ryan's prior deliverables. They knew the documents would be technically demanding, structurally elegant, and ahead of the state-of-the-art in multiple disciplines. The first slide of the executive summary loaded on the conference room screen. The title was a familiar phrase. Jaeger Program. The senior reviewer paused. A second reviewer, sitting at the far end of the table, blinked. Wait. Didn't we already evaluate this? The original Jaeger program proposal had crossed the panel's desk months ago. They'd produced a detailed evaluation, ambitious technology, plausible long-term value, unsupportable budget profile for a single-decade project. Their recommendation had been to fund the individual technologies separately while declining the full mech construction. But the file in front of them wasn't the proposal. The senior reviewer scrolled past the title page to the document index. Component-level engineering drawings. Materials specifications. Welding procedures. Fastener torque specifications. Assembly sequence diagrams. Cooling system schematics. Power distribution maps. Subsystem integration plans. The senior reviewer's breath stopped briefly. This wasn't a proposal. This wasn't even a feasibility study. These were construction blueprints. For a 250-foot, 1,700-ton combat mech. Get the chairman, the senior reviewer said quietly. Drawing manga/comic in Marvel. Chapter 108, The Acquisition Call. Jaeger Program. Target Spec, 250-foot, 1,700-ton humanoid combat mech. Construction documentation includes the following completed subsystem packages. Liquid Neural Multi-Pilot Connection Technology, production ready. Multi-lobed Plasma Cannon Technology, production ready. Trinity Horizon Gateway Operating System, design complete. Midnight 9 Toroidal Power Core, design complete. 87 additional subsystem packages listed below. The Aegis expert panel stared at the document index. At first glance, the file looked similar to the proposal they'd reviewed months ago. Same project name. Same conceptual targets. Same technologies listed. But each technology in the table of contents was followed by a status tag that hadn't existed in the original proposal. Production ready. Design complete. The reviewers looked at each other. Each of them understood what those four-word phrases meant. None of them were ready to believe what they meant. Click into one. Let's see what's actually there. The panel chair clicked through the title page and into the first subsystem documentation. Trinity Horizon Gateway Operating System. The page jumped to a hierarchical index that filled the screen. Subsection after subsection, each one labeled with technical specificity that the chair could feel was at production-grade depth even before opening any individual document. He clicked one at random. Dense technical content filled the display. Detailed engineering notes. Block diagrams. Code architecture maps. Data flow charts. Parameter tables. Specifications that read like a working operating system manual rather than a research proposal. This wasn't an outline. This wasn't a feasibility study. This was implementation documentation. Next subsystem. Quick. The panel members were on the edge of their seats now. The chair backed out to the master index and selected another entry. Mech underwater seal system. Another hierarchical drill down. Another wall of detailed technical content. The opening overview specified the system's design parameters: maintained pressure seal at depths down to 7,000 meters, hybrid static and dynamic sealing architecture, redundant secondary seals at all primary articulation points. 7,000 meters, one of the reviewers said quietly. That's deeper than most submarines operate at. And multi-layer redundancy means it can survive impact damage during operation. Even if the primary seal fails, the secondary and tertiary layers maintain integrity. This is submersible engineering. At Jaeger scale. Why does a combat mech need to operate at 7,000 meters? 3. Did anyone ask him this? The room was quiet. Nobody had asked Ryan about the operational depth specification. Everyone had assumed the mech would operate primarily on land, with limited shoreline and shallow water capability. The 7,000-meter rating was beyond anything they'd anticipated. The reviewers had done their homework on mechs from popular culture in preparation for this project, since none of them had backgrounds in giant robot engineering. Mechs in films and animated series typically operated on land or in space. Crimson Typhoon was apparently designed for an entirely different domain, deep ocean. The depth rating put the design firmly in the category of specialized for environments where no other military platform can operate. The implications cascaded. A combat platform capable of operating at 7,000 meters wasn't competing with land-based forces. It was operating in a strategic envelope that effectively didn't exist yet. Submarine forces had ceilings of approximately 1,000 meters for combat-rated platforms. Crimson Typhoon's specification was 7 times that. If the mech could actually achieve this depth rating, the technology underlying it would transform underwater operations across every domain. Civil submarines, deep-sea infrastructure, military submersibles, oil and gas drilling. The SEAL system alone was worth more than the entire mech program. 3. Continue. Next subsystem. The chair clicked through the structured index. Each subsystem followed the same pattern: full specifications, complete drawings, materials lists, fabrication procedures, integration plans. The package wasn't a research proposal asking for development funding. The package was a manufacturer's brief asking for production resources. After several hours of scheming, the panel had reached a consensus they hadn't been prepared for. This is buildable, one of the senior reviewers said finally. I have no idea how he got from concept to construction documentation in this time frame, but if these specifications are accurate, this thing can be built. We need to validate the specifications. Each subsystem needs independent technical review by domain specialists. That's going to take months. The chairman is going to want a recommendation faster than that. The chair closed his eyes briefly. He'd been on this panel for 15 years. He'd reviewed many large engineering proposals across that time. He'd never seen a single proposer deliver this much rigorous documentation. The depth and breadth of the package suggested an organization of hundreds of specialized engineers working for years. Ryan Mercer was one teenager. Working for, 8 months at this scale? The senior reviewer rubbed his temples and called for the chairman's executive assistant. Tell him we have something he needs to see. And brief him before he reviews. He's going to need preparation time. Meanwhile, several hundred miles away, James Alcott was on his 5th phone call of the morning. Are you sure you want to withdraw at this stage? Angel has actually received favorable reviews in international markets. The tactile feedback technology is genuinely advanced. The medical-grade applications for our prosthetic remain promising. The line went dead. Alcott looked at his phone, then placed it face down on his desk. That was the 4th investor in 2 days to terminate their commitment. He leaned back in his chair and exhaled slowly. The 2 months since Triton 1's launch had been a slow, grinding nightmare. Helios's Angel product, launched the same day as Triton 1, had suffered catastrophic comparative damage in the public reception. Tactile feedback didn't save them. Surgical requirement didn't save them. Premium positioning didn't save them. Triton 1 was simply on a different technology curve, and Helios couldn't catch up. Neuropath, Alkit's company, had been pursuing the same technology path as Helios. Surgery-based, targeted muscle reinnervation. The technology path that had just been demonstrated to be obsolete. For weeks, Alkit had been managing investor relations alone. The early-stage investors who had funded Neuropath's initial development were still committed, at least nominally. But the later-stage investors who had come in based on the surgical prosthetic market opportunity were exiting in waves. Each call from a panicked institutional investor was followed by a quiet meeting with legal counsel about contract obligations. Most of the exit clauses were enforceable. Most of the investors who wanted out were going to get out. Neuropath's runway was shrinking rapidly. The original problem had been that Triton 1 was better and cheaper. The follow-on problem was that with Helios crashing, every comparable surgical prosthetic company was being avoided by the market. Investors didn't want to fund the technology category at all. The entire surgical prosthetics industry was being downgraded in valuation models across the venture community. Alkit had been the rising star of the domestic surgical prosthetics market. Now he was a cautionary tale. His phone rang again. He picked it up. Alkit. His assistant. Cautious, careful voice. Dr. Alkit, I just received a call from a company expressing interest in acquiring Neuropath. I told them I would relay the message. An acquisition offer. Alkit sat up. In this market? Who's calling? The assistant hesitated. Prism Sciences. 1. Silence. Then Alkit actually laughed. 2. It wasn't a happy laugh. It was the laugh of a man who'd been outmaneuvered so completely that there was no remaining dignity in pretending otherwise. The company that had built the product that had destroyed Neuropath was now offering to buy Neuropath's wreckage at a discount. Alkit shook his head. Of course they were. From Prism Sciences' perspective, the math was straightforward. Neuropath had assets that Prism Sciences could use, regulatory approvals already in progress, medical relationships, surgical training programs, a brand recognized in the prosthetics industry. A targeted acquisition at the bottom of Neuropath's valuation cycle would give Prism Sciences a fully staffed surgical prosthetics subsidiary for less than the cost of building one from scratch. This was the second act of corporate strategy. Phase 1, destroy the competitor's market position. Phase 2, buy the competitor's assets at distressed pricing. 3. Alkit opened his mouth to refuse on principle. Then he closed it again. Neuropath was running out of runway. Refusing the acquisition would mean watching the company collapse, with every employee laid off and every patient relationship severed. Selling to Prism Sciences would mean accepting that his career as an independent founder was over, but the work would continue. The medical relationships would persist. The patients would still receive care. Neuropath as an institution would survive, just as a subsidiary. The pragmatic answer was the obvious answer. Take the call. What's the contact information? He asked his assistant. The assistant read it back. Alkit wrote it down. He stared at the number for a long time before picking up the phone. Drawing manga/comic in Marvel. Chapter 109, The Fitting Center. Snow was falling lightly on Manhattan. Jake Pierce walked along a sidewalk in Lower Midtown, wearing a down jacket with both hands jammed into the pockets. His mother walked beside him, alternating between scanning the buildings for street numbers and complaining about her husband. Your father couldn't take time off work, of course. Couldn't be bothered to show up for his own son. This is bigger than his stupid job and he still couldn't be bothered. Mom. And this weather. I hate this weather. It's been a miserable winter. I like winter. A gust of wind hit them from behind. The unexpected force knocked Jake forward a step. His left sleeve, which he'd carefully tucked into his pocket, came loose and flapped wildly in the wind, fluttering like a kite tail. I hate winter wind, though, Jake said. He used his right hand to catch the empty sleeve, tuck it back into the pocket, and re-secure it. The motion was practiced. A yellow cab pulled up to the curb. The driver had seen Jake's flapping sleeve and apparently assumed he was hailing. Jake's mother seized the opportunity. Thank God. Get in. They climbed into the back seat. The driver glanced at them in the rearview mirror with the unsurprised expression of a New York cabbie who had seen everything multiple times. Prism Sciences or Helios Fitting Center. Jake's mother had just finished settling in. Prism Sciences. How did you know? Jake slumped behind the driver's seat and muttered, "He saw my sleeve." The driver chuckled and pulled into traffic. These days, anyone walking through this neighborhood with a tucked sleeve is going to one of those two places. I run this route a few times a day. You've taken a lot of people there. Every day. Some are veterans, some are people in your situation, and now and then a wheelchair customer. I pick up the same people again a few days later when they come back for follow-up. The cab navigated traffic with practiced efficiency. The driver continued his commentary. How does Prism compare to Helios? Jake's mother asked. We visited the Helios location yesterday. The price is impossible. And Jake might not be a candidate for the surgery anyway. She unconsciously tightened her grip on her purse. The combination of prosthetic cost and surgical cost had put Angel out of reach the moment they walked in. The Helios consultant had been polite but had not pretended otherwise. The cabbie laughed. I never pick up return customers at Helios. They show off the technology, they take a deposit, the customer goes home and never comes back. Helios sells the future. Prism sells things that work. Is it really that different? You'll see when you get there. Their prosthetics move with you. The Helios prosthetics don't, not really. Word in the industry, people tell me, is that Prism is on a different curve. They've got something Helios doesn't have. I'm not the engineer, but I see who comes back happy. The cab continued its commentary on the differences between the two companies for the rest of the ride. By the time they pulled up to the Prism Sciences Fitting Center, Jake's mother had already mentally decided which one she trusted. The Prism Sciences Fitting Center occupied a small building near the edge of the commercial district, 2 stories with a converted ground floor. The street-facing window had been redesigned as a display case. Inside the window, a row of robotic mannequins demonstrated functional poses, their hands and arms equipped with Triton 1 prosthetics. The signature red flame motif on the arms had become a globally recognized brand mark over the past 2 months. Jake walked up to the glass and stared at the mannequins like a child looking at Christmas display lights. The mannequins were performing complex hand gestures, each prosthetic moving with the same fluid precision as a biological arm. The building wasn't downtown. They were on the western edge of the commercial zone. Despite the suburban location, the place was packed. Through the glass, Jake could see a busy interior with people moving through the space the way people move through a hardware store, looking, comparing, asking questions, trying things. This wasn't a luxury showroom. This was a working business. Mom. Let's go in. Jake actually grabbed her hand and pulled her toward the entrance. His mother followed, surprised and a little touched by the rare display of initiative. Welcome to Prism Sciences. A receptionist greeted them inside. Jake's mother put her hand on her son's shoulder. I'd like you to evaluate my son. We want to know if he's a candidate for a Triton 1 prosthetic. Of course. Let me get you registered. Which arm needs the prosthetic, and is there a specific fitter you'd like to work with? Left arm. Whichever fitter is best. The receptionist consulted a tablet. Our most senior fitter has a 7-day wait. Even our shortest wait fitter is booked 2 days out. 7 days. Jake's mother said, surprised. Yes. Our fitting schedule is very full. The good news, while you wait, we can run preliminary measurements today and begin developing your fitting plan. By the time your appointment comes up, the socket can be ready for installation. The lobby was alive with activity. Some visitors were waiting for their consultations. Others were touring the display areas. A small group at the back of the room was working with newly fitted prosthetics, going through adaptation exercises with Prism Sciences staff. Jake watched a man practicing finger movements with a freshly installed Triton 1. The man's expression was the same expression Jake imagined he'd have if he could feel his left hand again, focused, joyful, almost disbelieving. How many fittings have you completed? Jake asked. The receptionist considered. Worldwide, we've reached around 2,000 patients to date. This location is our highest volume international fitting center, though, so we account for a substantial fraction of that number. Cost? Jake's mother asked. The dread was visible in her shoulders. Within $40,000 for most full arm configurations. Slightly more than mid-tier conventional prosthetics, but the technology and aftercare service justify the difference. You can see the results in our active patients across the lobby. 5. She gestured to the patients training with their new arms. The price wasn't trivial, but it wasn't catastrophic either. It was approximately what they'd budgeted for the Helios consultation deposit alone. Jake's mother could see the path. Insurance might cover some of it. Medical financing could handle the rest. The numbers were workable in a way Helios's numbers had never been. She held her son tighter. Tell us about the process. Everything. In the Helios Group's headquarters, Michael Reeves sat behind his desk, listening to his executive assistant deliver a status report. The report could be summarized simply: Helios was losing in every measurable dimension. Triton 1 had better technology, better word of mouth, better pricing. Helios had only one remaining advantage: brand recognition, primarily generated by being the company that the public knew had been beaten by Triton 1. The brand recognition was a curse, not a blessing. Everyone knew Helios. Everyone knew Helios had lost. The bottom line was 3 words. We can't win. So you're telling me we need to withdraw Angel from the market? Reeve threw the report onto his desk. His assistant flinched and didn't answer. Reeve's mood had been progressively worse over the past 2 months. The smart move was to wait until directly addressed before speaking. Reeve drummed his fingers on the desk. Angel's commercial failure had been within expected parameters. Reeve had positioned Angel from the beginning as a brand investment rather than a profit center. The product was a marketing prop for the company's valuation uplift in the upcoming Series E funding round. The problem was that the brand investment had inverted. Angel was no longer associated with the future of human augmentation. Angel was associated with the product that lost to Triton 1. That branding actively hurt Helios's valuation. Investors were treating the company as overexposed rather than visionary. His Series E timing was slipping. Each week of delay was costing tens of millions in opportunity cost. His assistant finally spoke, carefully. Sir, I have one alternative strategy that might recover the position. Reeve looked up. Speak. We could pursue a regulatory action against Triton 1. File complaints with the relevant federal agencies. Argue that Triton 1's underlying technology has not been adequately tested for long-term neurological safety. Brain-computer interfaces are still considered experimental in most regulatory frameworks. We could request a federal review and a temporary suspension of sales pending the review's conclusion. 2. Reeve raised his eyebrows. He understood the strategy immediately. Use Helios's institutional weight, lobbying relationships, regulatory contacts, government affairs, to weaponize the safety framework against a competitor. The strategy wasn't unprecedented. Established companies had used regulatory friction to slow disruptive entrants throughout industry history. A permanent ban would be impossible. Triton 1 was a consumer prosthetic, not a strategic technology. The government wouldn't shut it down purely for competitive protection. 1. But a temporary suspension during a safety review was achievable. 6 months, maybe 9, while regulators worked through the safety documentation. During that suspension, Triton 1 couldn't sell in the domestic market. The competitive pressure on Angel would ease. Reeve could complete his Series E. After the funding round closed, Angel's commercial performance was no longer Helios's strategic concern. How fast can we move? Filings can be prepared within a week. The initial review process for a contested medical device can take 3 to 6 months. With the right introductions, we might get an emergency review window opened in 2 weeks. Do it. Brief the legal team. Pull the government affairs files. We move. The assistant nodded and left to begin coordination. Reeve leaned back in his chair and lit a cigar. The cigar tasted better now than it had in 2 months. 2. Drawing manga/comic in Marvel. Chapter 110, The Suspension. Helios's move came fast. The legal filings, the regulatory contacts, the agency briefings, all of it executed in days rather than weeks. By the time Prism Sciences became aware of the action, the order had already been signed. The first sign was an unfamiliar man walking into the New York fitting center. He was a federal compliance officer. Tall, professionally dressed, carrying a leather portfolio. He went directly to the manager's office without checking in with the reception desk. The fitting center's manager, Edward, looked up from his computer. Mr. Walker. The officer placed a signed document on the desk. We've received a formal safety complaint regarding your product. The complainant alleges that Triton 1 prosthetics may have the capability to manipulate the wearer's neurological functions. As a precautionary measure, we're issuing a federal inspection order. Effective immediately. 2. Edward picked up the document. The text matched what the officer was saying. He blinked twice and read the operative paragraph again. Pending the completion of our safety review, your company is required to halt all sales activity in the domestic market. You must also continue providing maintenance and follow-up services to existing customers, as part of your ongoing duty of care. Edward stared at the document for a long moment. Our product has cleared every regulatory review process. It's fully approved. We are FDA compliant. Why would a single complaint trigger a halt in sales? The compliance officer didn't answer. Our prosthetics don't have wireless capability. There's no antenna in the device. There's no signal transmission pathway. The premise of the complaint is impossible. We can't control brain waves because we don't transmit anything to the brain. The neural interface is one-directional. We read from the user. We don't write to the user. Edward heard himself speaking faster, more frustrated. He was building a technical defense to a complaint that wasn't actually about technology. The officer continued not to answer. If our prosthetic could control brain waves, we'd be calling it something more dramatic than Triton 1. We'd be calling it the Mind Control Mark 1. The officer shrugged. That single gesture told Edward everything. The complaint was a pretext. The compliance officer knew it was a pretext. The agency knew it was a pretext. But the order had been signed by someone with the authority to sign it, and the agency was required to act. Edward closed his eyes briefly. Picked up the phone. I'll inform corporate headquarters. The officer nodded politely and gestured at the door. Take your time. I'll wait outside. He stepped into the lobby and motioned to 2 more compliance staff who had been waiting near the entrance. They began their assigned task, clearing the customers from the building. The receptionist began explaining to the visitors. Sir, ma'am, I'm sorry. We're required to suspend operations during a federal safety review. We can't perform any new fittings until the review is complete. What about other cities? Can I get fitted somewhere else? The order applies nationally. All Prism Sciences fitting centers in the country are required to suspend operations. The compliance officer made a brisk gesture toward the lobby's exit. The receptionists and floor staff began politely directing customers toward the door. Sir, please. Wait, you haven't explained how I can finish my fitting. Sir, please exit the building. No, you haven't actually answered my. Fuck. Outside, snow was falling steadily. Jake and his mother had been pushed onto the sidewalk along with the other customers. The fitting center's front door was closed behind them. The display window curtains were drawn. The sign in the window had been changed to red temporarily closed for federal compliance review. Jake's mother was speechless. She'd just spent the entire morning completing the fitting preparation. Jake had been waiting for his appointment date. They were finally on track. And now they weren't. Mom. Jake said quietly. What do we do? She looked at her son. She wanted to give him an answer. The answer she had wasn't one she wanted to deliver. Let me think. Let me figure out other options. She didn't know what those other options were. Helios was out. They couldn't afford it. The other domestic prosthetics manufacturers were running myoelectric products that had been definitively eclipsed by Triton 1 in functionality. The remaining brain-computer interface companies were all either subsidiary brands of Helios or research programs at universities. None were available for consumer purchase. Around her, other ejected customers were vocalizing the same realization with substantially more profanity. Inspection my ass. They've got a problem with the company, so they shut down the whole industry. How is this an emergency safety issue? My friend's been wearing one of these for months. He's fine. He's better than fine. He can pick up his kid for the first time in 8 years. That's the safety issue. Let's drive to another city. There has to be a fitting center somewhere. It's national. They said. National. Then what the hell do we do? A group of customers piled into a waiting car. The collective decision seemed to be that they would visit another Prism Sciences location to confirm the suspension was real and not a single site error. They drove off into the snow with grim determination. Jake's mother caught Jake's elbow. We'll figure something out. I promise. She didn't know how she was going to keep that promise. The story reached Prism Sciences headquarters that evening. Over the past 2 months, Triton 1 had been one of the most discussed products in domestic media. Every minor news item involving the company had been amplified across coverage outlets. Every customer testimonial had been shared widely. The product had become, in the framing of one major media analyst, a quiet symbol of American innovation. 1. The federal suspension order was the opposite of a minor news item. By midnight, it was the top trending business story across every major platform. Tom was woken by an urgent call from Hudson. He took the call, listened to the situation, and ordered an emergency leadership meeting via video conference within the hour. The discussion was direct. The suspension order had to be respected. Prism Sciences couldn't ignore a federal order, even one based on a transparently fabricated premise. Continued operations would compound their legal exposure. The question was how to get the order rescinded. Who do we think filed the complaint? One of the senior staff asked. Tom didn't hesitate. Helios. There was no one else with the motive, the institutional connections, and the regulatory access to engineer this kind of move. The timing relative to Helios's Series E was the smoking gun. The complaint had been filed in the window where a temporary suspension would maximally damage Triton 1's market position and maximally protect Angel's fundraising timeline. I'll make some calls, Tom said. Hold steady. The suspension is temporary by definition. We'll get it rescinded. Make sure the field teams maintain warranty service for existing customers. We won't lose our patient base over this. The leadership signed off. Tom poured himself a drink and started thinking through his network of contacts. He had friends. He had a lot of friends. The question was which of them had the right kind of leverage to unwind a federal compliance action. After 15 minutes of thinking, he dialed an international call. Ryan didn't hear about the suspension until breakfast the next day. He was eating a steamed bun at the cafeteria when one of the technicians mentioned it casually. Did you hear what happened to your dad's company? They got shut down by the feds last night. Ryan paused mid-bite. What? Suspension order. The story's all over the news this morning. Federal compliance review. Allegations that Triton 1 can do mind control or something. Ryan put down the bun and pulled out his phone. The story dominated his feed. Within minutes, he'd pieced together the full picture. A complaint had been filed, a suspension order had been issued, the New York fitting center had been forced to close mid-operation, customers had been physically ejected from the building, and the same pattern had replayed at every other domestic Prism Sciences location. A video had been posted by a bystander showing a crowd of disabled customers being pushed out of the New York fitting center into the snow. The video was being viewed millions of times. The comments were vicious. This is the most disgraceful thing I've seen the agency do in my lifetime. They escorted disabled people into a snowstorm. The suspension reason is mind control. Mind control. Mind control. My country, ladies and gentlemen. Triton 1 is genuinely good. My friend has one. She's gone from someone who wouldn't leave the house to someone who texts me memes. That's the safety issue. If I had any reasonable use for one of these, I'd be ordering one out of spite right now. Wait. Did the report actually say mind control? Suddenly I'm less sure I don't have a use for one of these. The Prism Sciences corporate account had posted a brief response. We've been falsely accused. The reply thread was uniformly supportive. We protect Prism. Ryan stared at the screen for a moment. Then he called his father. Drawing manga/comic in Marvel. Chapter 111, Care and Support. You saw the news, Tom said. His voice was tired. He'd been up all night and was running on coffee and the kind of focus that only adrenaline can sustain. He yawned audibly into the phone. How serious is it for the company? Ryan asked. Cash flow okay? Tom didn't sound worried. There was the sound of him sipping something, probably tea or more coffee. Don't worry about the operations. I'll handle them. The suspension only stops new sales. It doesn't claw back the revenue we've already booked. That money is in the bank. As for cash position, we have several months of runway on hand. If we bring international revenue back to the domestic account, we extend further. And here's the kicker. I had 3 banks call me this morning offering credit lines. 1 zero interest line, 2 low interest. The suspension news is actually accelerating our financing options. Don't ask me why. Tom's tone was steady throughout. Not a hint of panic. I've already started working the network to get the suspension lifted. This isn't going to drag on. The transparent absurdity of the complaint will help us. It'll be much harder for the agency to defend a 6-month review when the underlying premise is mind control. The only real impact is on our expansion plans. I was negotiating to acquire 2 domestic prosthetics startups. Neuropath we already closed. The other 2 are now on hold. Neuropath plus our internal team is enough to run the V2 design without additional acquisitions, Ryan said. Mason's group has the capacity. The other 2 startups can wait. Tom continued with the operational update. In the 2 months since the launch, Prism Sciences had completed approximately 1,000 fittings domestically and over 2,000 internationally. Domestic revenue was approaching $100 million. International revenue, in the same currency, was approaching another $100 million. After taxes, the cash flow was supporting full operating expenses with margin to spare. And Prism Sciences was operating under a 5-year tax exemption that the chairman had granted in exchange for Ryan's hold on the reactor patents. The exemption rounded out to approximately 100% reduction in federal tax burden, with the possibility of extension for high-performing companies. The tax exemption had been announced shortly after the Triton 1 launch. Several other domestic tech companies had been excited at the time, assuming the policy was a general one that they might also qualify for. The final list had been a single company, Prism Sciences. Ryan absorbed the financial picture. The cash flow was healthy. The company wasn't going to fail. The suspension was an annoyance, not an existential threat. He thought for a moment. International business is going to be hard while domestic operations are suspended. Maybe we focus expansion on countries with stable trade relationships with us. There are markets we haven't entered yet that don't have the same regulatory dependencies. Already on it. Leadership and I discussed exactly this last night. We're sending teams to evaluate 3 new markets within the next week. Ryan tapped his fingers on the cafeteria table. Another idea was forming. Or, he said, we bring foreign customers domestically. Wait. Sell to foreign customers but install here. Right. International patients fly into our domestic fitting centers, get fitted here, fly home with their prosthetic installed. The local authorities can't suspend something that was sold and installed outside their borders. The customer comes home with a fitted prosthetic. Customs treats it as personal medical equipment, like a pacemaker or insulin pump. We supply parts to local partner centers for follow-up maintenance. 2. Tom paused. Ryan could hear him processing. Foreign patients traveling abroad for prosthetic care isn't unprecedented. Medical tourism is an established industry. People travel for cosmetic surgery, dental work, even joint replacement. Why not prosthetics? And it sidesteps the suspension entirely. The agency can't regulate what they don't have jurisdiction over. Right. The product enters their country in the customer's possession, as personal medical equipment. The customer crosses customs with their prosthetic already installed. Nothing to declare. Nothing to seize. Just an amputee with a prosthetic. Is that allowed? It's not disallowed. People travel with medical implants all the time. There's no specific regulation prohibiting it. The agency would have to invent a new framework to stop it, which would take longer than our suspension hearing. Tom laughed for the first time during the call. I love this. We turn their attack into a marketing campaign. Foreign patients lining up to fly into the country for the prosthetic. Medical tourism inbound. The optics on this are going to be incredible. And every patient who travels here for fitting becomes a marketing testimonial when they return home. Genius. We'll start logistics planning this week. Coordinating airport pickup, hotel partnerships, expedited fitting schedules. I have a couple of friends in the travel industry who can move on this fast. The conversation continued for a few more minutes. Tom was visibly more energized by the end of it. He'd entered the call exhausted and looking for reassurance. He'd left with a plan that turned the suspension into an opportunity. Talk soon, Tom said. Don't worry about anything. He hung up. Ryan shook his head, smiling. His father's recovery time was always faster than expected. A new message appeared on his phone. Chloe. Just saw the news. Is the company in trouble? Ryan settled back in his chair and replied with characteristic casualness. Not really. Just temporary inspection drama. Dad's already handling it. Nothing major. He hit send and looked up. Kyle was sitting at a nearby table, watching him with concern. I heard about the suspension. Is everything okay? Ryan rubbed his face. He'd been asked this question approximately 5 times since breakfast. He stood up, walked over to Kyle's table, and clapped him on the shoulder. It's fine. Stop worrying about it. By the way, I hear you've been working on a new research thread. How's that coming? The shift in topic landed exactly where Ryan had aimed. Kyle's face went through the same shade of green that a student's face goes through when their teacher asks about summer homework that was due last week. That bad? It's coming along. Walk me through what you have. Kyle started to walk through what he had, with the visible reluctance of someone who knew he was about to be inspected. While Ryan was at the cafeteria conducting impromptu homework checks, something significant was happening in the broader news cycle. The National Disability Advocacy Organization, NDAO, released an announcement. NDAO had committed $200 million to a new charitable initiative. The program, named the Lotus Initiative, would over the next 5 years fund prosthetic installations for up to 20,000 domestic patients. The goal was to improve quality of life for disabled individuals while enabling them to participate more fully in the workforce and the broader economy. 1. NDAO was a domestic charitable advocacy organization with a quiet public profile. Most of the time, the organization's media presence was limited to occasional reports on accessibility legislation. NDAO rarely made national headlines except when there was a corruption scandal in the broader nonprofit sector. Today, NDAO was the lead story on every news platform. The announcement didn't name Prism Sciences specifically. But the timing was unmistakable. A $200 million prosthetic funding program announced in the immediate aftermath of Triton 1's federal suspension was an obvious political signal. NDAO was telling the federal agency that there were institutional players who considered Triton 1 essential infrastructure for disabled Americans. NDAO was telling Helios that the regulatory attack had attracted counter-moves from organizations with their own political weight. The comments rolled in. Lotus Initiative? Okay, I see what NDAO is doing. Nicely played. Lotus, Triton, the symbolic flower of clarity versus the messenger of the sea. Subtle, NDAO. Very subtle. 1. This is a coordinated response. I love it. I was worried this might be the end of Prism Sciences. I'm less worried now. This is the kind of program that turns a regulatory issue into a political issue overnight. Helios is about to have a much harder time keeping their suspension intact. Disabled Affairs charity announcing $200 million to subsidize the product that just got suspended. The agency director is going to have a long week. The Lotus Initiative was a public policy weapon disguised as a charitable program. NDAO was making the political cost of maintaining the suspension significantly higher than it had been 24 hours earlier. The agency would now face questions not just from technology journalists but from disability advocates, civil rights organizations, and the segment of the political coalition that prioritized accessibility issues. The suspension wasn't going to last 6 months. The suspension wasn't going to last 6 weeks. Tom's friend, somewhere, had moved fast. Drawing manga/comic in Marvel. Chapter 112, The Foreigners You Can't Stop. Where can I get a Triton 1 installed? Jake's mother typed the question into her search bar. Jake sat slumped on the couch beside her, scrolling listlessly through his phone. The wallpaper on his screen was the Triton 1 logo, the red flame motif against a dark background, the brand mark that had become globally recognizable over the past 2 months. His mother scrolled through the search results. There's a fitting center in New York. And one in Los Angeles. And listings for several other cities. But every one of those results predated the suspension order. After the federal compliance review had been triggered, every Prism Sciences fitting center in the country had ceased operations. The search results were a list of locked doors. Then a new answer caught her eye. It had been posted 2 days ago and had already accumulated a large number of upvotes. If you want a Triton 1 installed right now, here's a complete guide. First, book a flight to Rivermont, the city where Prism Sciences is headquartered. When you land, you'll find taxis at the arrivals exit. Your first stop is Rivermont Central Hospital. You need an outpatient medical evaluation before a prosthetic can be fitted. The doctor will review your medical history and assess your physical and psychological readiness for the prosthetic. The evaluation report is usually issued within 2 hours. With that report in hand, take a taxi to the Prism Sciences Fitting Center. There will be taxis waiting outside the hospital. At the fitting center, present your evaluation report and explain that you've traveled for a fitting. They will be glad to help you. You can also ask the fitting center staff for lodging assistance. They can recommend nearby hotels. You don't need to worry about post-installation maintenance. Prism Sciences operates a global warranty program. Any prosthetic fitted at one of their centers can be serviced at any Prism Sciences fitting center or service center worldwide, regardless of where it was originally installed. Those are the main steps. Below are the details: how to communicate your destination to taxi drivers, how the hospital registration process works, currency exchange information, and more. Please read all the way through. The guide was exhaustively thorough. It specified which window at the Rivermont Airport currency exchange to use. It explained the hospital's registration and queuing process. It included photographs of both Rivermont Central Hospital and the Prism Sciences fitting centers so travelers would recognize the buildings. Anyone following the guide step by step could complete a prosthetic fitting without speaking the local language or having any prior familiarity with the city. The level of detail was the giveaway. No casual traveler could have produced this. The guide had been written by someone with deep, current knowledge of Rivermont. Someone, in all likelihood, who worked for Prism Sciences. The guide spread across the internet rapidly. Within days, every prospective Triton 1 customer in the country had seen it. Flights to Rivermont sold out. Prosthetic candidates and their families bought every available seat. Jake and his mother managed to secure 2 adjacent tickets. When they boarded the plane, they discovered something. The cabin was full of people with hand and arm disabilities. Empty sleeves. Visible prosthetics of older designs. Wheelchairs at the gate. The passengers looked at each other and exchanged small, knowing smiles. Everyone on the flight was going to the same place, for the same reason. Over the following days, the residents of Rivermont noticed something unusual. There was a sudden surge of foreign visitors. Many of them had visible hand or arm disabilities. They tended to cluster in 3 places: Rivermont Central Hospital, the Prism Sciences Fitting Center, and the currency exchange counters at the major banks. The Prism Sciences Fitting Center, which had seen its foot traffic decline as the initial launch rush faded, suddenly surged back to capacity. The lobby was packed every day, full of English-speaking visitors working through the fitting process. The atmosphere recalled the chaotic first days after the launch. 2. And the number of foreign visitors kept growing. There was no sign of it slowing. A phenomenon this visible couldn't stay quiet for long. Reporters picked up the story. It went to broadcast. Television coverage showed foreign visitors, faces blurred for privacy, arriving at the Rivermont Airport and immediately consulting their saved copies of the guide. The footage followed the process step by step. First, the visitor approached a taxi and showed the driver the guide's image 1, a line of text reading "Take me to Rivermont Central Hospital." At the hospital, the visitor showed the staff image 2, "I need an outpatient evaluation for prosthetic fitting." The audience watching the broadcast was, by the reporter's description, collectively stunned. The internet reaction was immediate. Incredible! Look at Prism Sciences go! A guide this detailed had to be written by a Prism employee. No question. Confident version, drop the had to be. It was a Prism employee. This is the first time I've seen foreign customers chase a product across an international border. I genuinely can't process it. Think about it from their side. Every person with a hand disability wants their hand back. That's the most fundamental demand there is. If I heard there was a prosthetic this good at a price I could afford, in another country, I would absolutely find a way to get there. This is what happens when your technology is genuinely ahead. Your competitor can pull every dirty trick available and it still doesn't matter, because the customers will walk through fire to reach you. Across the border, in the country where the suspension order had been issued, the medical tourism surge was impossible to ignore. The flights to Rivermont were full of the country's own citizens, hand-disabled customers traveling abroad with family escorts. The story had crossed back over from foreign coverage into domestic media. Television panels were discussing the phenomenon. Helios pushed for a response. There wasn't one available. The suspension order had no jurisdiction over Prism Sciences operations in other countries. The agency couldn't order a foreign company to stop serving the agency's own citizens abroad. If they tried, the logic would collapse immediately. It would be equivalent to demanding that a smartphone manufacturer check the nationality of every buyer and refuse to sell phones to citizens of a particular country. The premise was absurd on its face. They couldn't forbid their own citizens from receiving prosthetics abroad, either. That was even more absurd. A government telling disabled citizens they were not allowed to get medical care in another country was not a policy any official wanted to defend in public. And as for intercepting the prosthetics after installation, nobody was going to stand at the border and forcibly remove medical devices from disabled travelers. The footage of customers being ejected into a snowstorm had already done enough reputational damage. The footage of customs officers amputating people's prosthetic arms would end careers. So the medical tourism continued, and the authorities looked the other way, and Helios's lobbyists ran out of moves. During the entire period of the suspension order, Prism Science's fitting centers in the affected country never reopened. They didn't need to. Instead, Prism Sciences opened several additional service centers in the country, purely for warranty and maintenance support. The service centers weren't sales operations, so they didn't violate the suspension. They existed to support the growing population of customers who had traveled to Rivermont, gotten fitted, and come home with a working Triton one arm that occasionally needed a tune-up. The suspension order, designed to choke Prism Sciences out of the market, had instead generated a stream of international medical tourists, weeks of positive press coverage, and an expansion of Prism Sciences' service footprint. Helios had fired a weapon and watched it curve back around. 1. Drawing manga/comic in Marvel. Chapter 113, A Difficult Choice. They're opening at least 5 more service centers in other cities. In the Helios CEO's office, Michael Reeve listened to his assistant's report and lapsed into silence. Ever since the medical tourism surge had begun, Reeve had been working the media, trying to suppress coverage of the phenomenon, hoping to keep it quiet at least until Helios completed its funding round. He'd failed. Reeve had public relations capability. So did his opponent. Prism Sciences had simply counter-lobbied the same outlets Reeve was lobbying. The story ran anyway. It generated extensive public discussion. The narrative was now widely understood. Triton 1 had been temporarily suspended, but the product hadn't disappeared. It had relocated its center of gravity to its home country, and customers were chasing it across international borders to get it. 1. Meanwhile, Angel remained largely ignored. That wasn't entirely accurate. Angel still found occasional buyers, wealthy disabled customers willing to pay a premium for the tactile feedback feature. But those buyers were rare. For most of the market, Angel's price point positioned it as a luxury item. The trouble was that prosthetics didn't have a luxury tier. A prosthetic was a tool. People chose the prosthetic that worked best for the price they could pay. There was no prestige in an expensive prosthetic the way there was prestige in an expensive watch. A prosthetic that cost 3.5 times more and did less wasn't a luxury good. It was just a worse product with a higher price. After a long silence, Reeve spoke to his assistant. Push the funding round back. We'll wait until this news cycle passes. Understood. The assistant wasn't surprised. It was the correct call. The medical tourism story had spread far enough that Helios's prospective investors had certainly seen it. The investors would already be sharpening their knives, waiting for Helios to open the round so they could use the bad press as negotiating leverage. Everyone involved understood that Angel's commercial failure was, in strict financial terms, immaterial to Helios's overall health. Helios was a large, diversified company. Angel was one initiative. But immaterial facts could still be weaponized in a negotiation. Opening the funding round now would mean accepting a lower valuation. Better to wait. Reeve picked up a cigar and was about to light it when another thought occurred to him. Cut the Whitfield Labs research budget by 50%. Angel's control architecture is obsolete. Tell them to pivot toward non-invasive cortical acquisition, the approach Prism Sciences uses. If they can't make that transition, we'll find a lab that can. Understood. The assistant noted it. Should the PR campaign against Prism Sciences continue? Reeve exhaled. No. The campaign failed. Continuing it just wastes money. Tell the outlets to leave us out of their coverage from now on. He closed his eyes and let smoke curl from the cigar. I'll go, then. Go. A short while later, Professor Andrew Whitfield received a call in his lab. The assistant opened with the purpose of the call directly. Whitfield broke into a cold sweat as he listened, hoping he'd misheard. A 50% budget cut. And you want us to pivot toward Prism Sciences' technology path? Correct. If your team isn't capable of the new research direction, we'll find a better option. The assistant's tone was cool and procedural, like a recording. Whitfield tried to argue. Our technology isn't far behind. Both approaches have their own advantages. Our system restores tactile feedback. Theirs can't do that. We have a genuine differentiator. He spoke for a long time, until his throat went dry. The voice on the other end didn't change at all. The company has made its decision. It's not reversible. I'm only the messenger. Good luck, Professor. The line went dead. Bloodless capitalists, Whitfield said, nearly hurling his phone across the room. Do they think changing technology paths is like making a U-turn on a highway? He slammed the phone onto his desk. His beard practically bristled with the force of his anger. His students and researchers, sensing the temperature in the room, lowered their heads and found urgent reasons to look at their workstations. Whitfield's gaze fell on the object in front of him. A Triton 1 full-arm prosthetic sat on his lab bench. He'd been studying it for days. Just before the assistant's call, he'd been wearing a sensor cap, operating the Triton 1 across his desk, trying to reverse engineer its behavior. The research had not been going well. The two technology paths looked similar from a distance. Up close, they were profoundly different. The core of Triton 1's technology was the precise, rapid identification of neural signals from the cerebral cortex. The hardest part was the algorithm, the software that decoded the noisy, low-amplitude cortical signals into clean motor commands. Whitfield's approach was different. His method surgically transplanted nerves to the residual limb, where the relocated nerves produced clearer, stronger signals. His approach demanded much less of the decoding algorithm because the signal it received was already clean. Whitfield thought of an analogy. Imagine a rice bin holding both white rice and glutinous rice, mixed together. Triton 1's technology found and extracted the glutinous rice grains from the mixture every single time, instantly, with perfect accuracy. Whitfield's technology took the glutinous rice out of the bin in advance and set it aside, so it was easy to grab when needed. By that analogy, Whitfield's approach was obviously the smarter one. Why solve a hard sorting problem in real time when you could just pre-sort? He'd believed that. Right up until Triton 1 launched. His comparatively simple approach had only just reached production maturity. And the teenager across the ocean had already completed a vastly harder technical achievement, the real-time cortical decoding that Whitfield's entire field considered impractical. 1. Pivot the technology path, Whitfield muttered, setting the sensor cap aside. Pivot. He didn't know whether he should do it. He couldn't be certain he'd be able to produce results on a new path. He'd spent decades on his current technology. He'd given it his youth and his energy. He'd been on the verge of his career's defining achievement. And now he was being asked to abandon all of it and start over. It was an extraordinarily difficult choice. And Whitfield wasn't the only one facing it. Triton 1's success had been a seismic event for every brain-computer interface research institution in the world. Many neural prosthetics labs faced the same choice Whitfield faced. Follow the path Prism Sciences had cleared and develop non-invasive cortical prosthetics, or continue down their own established roads. One path was proven but new to them, a route someone else had already traveled successfully, which meant abandoning their accumulated expertise to walk a stranger's trail. The other path was familiar but dimming, the road they'd traveled for years, now leading toward a destination the market no longer wanted. Many researchers were still wavering, waiting to see how the situation developed before committing. But the reverse engineering effort had already begun. Research institutions and competitors around the world wanted to understand the technology behind Triton 1, especially the decoding algorithm. They wanted to crack it, study it, replicate it. They couldn't. Ryan had wrapped the algorithm in an encryption scheme of considerable sophistication. Side-channel attacks, the most effective method for extracting protected algorithms, produced nothing useful. Other extraction methods failed similarly. Worse, attempts to breach the encryption frequently tripped the device's security protocols, which would lock the neural control unit and render it permanently inoperable. Per the purchase agreement, a device locked by tampering was not covered under warranty. So no one had managed to get a single look at the algorithm. The encryption strength was incongruous with a prosthetics company. It was the kind of security architecture you'd expect from a defense contractor or a top-tier cybersecurity firm, not a medical device manufacturer. It led many observers to a quiet conclusion: if Prism Sciences ever decided to enter the computer security industry, the company had the capability to become a dominant player there too. What kind of prosthetics startup encrypted its products like state secrets? 1. The answer: though no one outside the company knew it, was simple. The encryption hadn't been written by a prosthetics startup. It had been written by Ryan Mercer, working from the same system documentation that had given him a Jaeger drawing manga/comic in Marvel. Chapter 114, Feasibility Confirmed. Aegis Industrial. A conference room. Reports of varying thickness were stacked on the conference table. In the center, the documents had accumulated into a small mountain. The man at the head of the table spoke. These are the feasibility reports collected over the past period regarding Crimson Typhoon. Nothing leaves this room. We'll divide the reports and review them today, then tally the results. We have new faces in the room. If you have questions, ask the person next to you. Time is short. We won't be discussing this at length. He distributed the mountain of documents around the table, took the first report from his own pile, and began reading. When Aegis had received Ryan's complete Jaeger blueprints, the company had distributed the subsystem documentation to domain specialists for confidential feasibility review. Every subsystem outside the original panel's expertise had been routed to the appropriate experts. The reports on the table now were the returned assessments. Compared to the original Jaeger program review, the conference table had several unfamiliar faces. The new arrivals looked at the document mountain with visible confusion. What are these reports? The new members picked up documents and quickly discovered something. The reports spanned an enormous range of disciplines. Mechanical engineering, electronics, computer science, materials science. The breadth was bewildering. And some of the reports were assessments the new arrivals had personally authored. That was, in fact, why they'd been invited to this secretive company as technical consultants in the first place. What exactly are we reviewing? A young new hire asked the veteran Aegis employee seated beside him. The veteran smiled faintly and handed him a particular document. Take a look. The new hire opened it. A rendering of Crimson Typhoon appeared on the first page, accompanied by performance specifications. He set aside the dizzying spec sheet and kept reading. The following pages contained a long technical manifest. The items on the manifest appeared to correspond to the reports he'd just been skimming. He flipped back to the first page and looked at the performance specifications again. A 250-foot, 1,700-ton humanoid combat mech. The new hire blinked. These reports are the technical design for this mech? It can actually be built. The veteran seemed to enjoy the younger man's bewilderment. You're holding its feasibility report. The reports will tell us whether it can be built. The new hire processed this. Then another question surfaced. This isn't connected to that teenager, is it? In the current environment, anyone who heard the word mech thought of Ryan Mercer first. The veteran answered with the calm of someone who'd been here a while. Nobody else on the planet could design a mech right now. Our daily job here is receiving and reviewing his technical deliverables. The rest of our time, we do our own research. The new hire noticed a further implication. He looked at the long list of technologies on his document and swallowed. These aren't all one person's work, are they? You guessed right. That's exactly why we're here to vet it. You'll get used to it. Some people's brains simply work differently from everyone else's. The veteran was unbothered. He patted the young man's shoulder. Looking at the new hire, he saw a version of his own younger self, the version that had not yet adjusted to the existence of Ryan Mercer. If you hadn't seen it with your own eyes, who could believe a person like that existed? Item 135. Gyroscopic stabilizer design. No issues. The veteran checked the result on his current report and placidly marked a check mark next to item 135. The review continued from morning into the late night. When the conference room's lights finally went dark, security personnel collected every report and incinerated them on site. Nothing remained but ash. The feasibility study passes, the man at the head of the table said, taking a sip of strong tea to keep himself alert. I'll report the result to headquarters. Thank you all for your work today. 1. Nobody was surprised by the outcome. The results in the reports had been close to ideal. There wasn't a single low feasibility conclusion anywhere in the stack. Every assessment came back rated high feasibility. I wish my grandson had that kind of ability, someone said wistfully. The others laughed. The sentiment was widely shared. Ryan was staring blankly at the project progress in his system. The development progress had reached 5%. He hadn't done anything recently to generate summon points, and the progress had still climbed fairly quickly. That probably meant the new project wasn't an especially difficult one. The past stretch of time had been a rare period of rest for him. The new system project had not yet produced any results to study. Every research project at Dome Base was progressing smoothly. The teams could complete their work without him. Mason's group was studying lower limb prosthetics and the associated neural systems, with no new development assignments pending. For the first time in a long time, Ryan was contending with an unfamiliar sensation: he was bored. He had nothing pressing to do, and he was looking for something to fill the time. I'll watch it. Bye. He finished a phone call with Chloe and pulled up the television series she'd recommended. He propped his chin on his hand and watched for a while, then concluded it wasn't very interesting. He logged into his social media. His feed was full of comments from the usual community of internet goofballs. Several people were asking whether he'd be returning to school to take exams. A number of people had been visiting MIT to take photos with the giant footprint Scrapper had left during its live-streamed run across the campus. Ryan only now learned that the road surface Scrapper had crushed during the test had never been repaired. It had been preserved and cordoned off behind a decorative railing. He wondered whether President Callaway had taken his original suggestion. The cracked road had effectively become a minor tourist attraction with global recognition. It was described online as a pilgrimage site for mech enthusiasts and engineering fans. The people photographing themselves there came from all over the world. Beyond domestic tourists, there were foreign dignitaries who visited while traveling for diplomatic purposes. The cracked road had, somehow, acquired a modest diplomatic function. Ryan also noticed that many of the people photographing themselves at the site had Triton 1 prosthetics. The foreign visitors especially. They had presumably traveled to Rivermont for the prosthetic and stopped at the MIT site for sightseeing. He searched the internet. As expected, on the foreign platforms, beneath the prosthetic installation guide Tom's people had written, someone had now appended a tourism guide. Patricia found him there. She walked into his quarters, wiped a thin film of sweat from her forehead, caught her breath, and noticed the television series playing on Ryan's computer. "You watch television?" She'd assumed Ryan's life consisted entirely of family, research, and sleep. She'd previously considered asking the base's psychologist to check in on him. Ryan yawned. "Someone recommended it. It's not very good." "What's going on?" "Your earlier project has a new result." Patricia remembered her reason for coming. "The company's feasibility study has passed." Ryan sat up. He was suddenly very awake. Drawing manga/comic in Marvel. Chapter 115, Chief Designer. "So when can the project start?" Ryan asked. He pulled a large bottle of chilled cola from his dorm refrigerator as he spoke. Drinking cola in the middle of winter was a little strange, but happy moments called for the happy drink. The logic was sound. 1. Patricia sighed. She sat down across from him and spoke with the gravity of someone delivering an important message. "The response I got from leadership is that the technology has cleared feasibility. There are no technical obstacles. But before the project is formally approved, there's one thing they need to confirm with you." She looked at him seriously and asked the question the company had instructed her to ask. "If the project goes forward, will you participate publicly as the chief designer? In the official announcements and the press coverage?" "Of course I will." Ryan didn't hesitate for even a second. He said it like it was the most obvious answer in the world. Patricia had guessed that would be his response. The company had, some time ago, built a dedicated psychological and behavioral profile of Ryan. The analysis had reached a specific conclusion: his personality included a strong streak of showmanship. It had previously manifested in his video production and his live streaming. Since coming to Dome Base, the impulse had been somewhat restrained, but it had never disappeared. There was no chance Ryan would choose to conceal his role in the Crimson Typhoon project or downplay his position. Patricia delivered the warning anyway. "I have to be honest with you. If you participate as chief designer, the public reaction is not going to be calm." It didn't take much imagination. A 14-year-old, no, a 15-year-old, becoming the chief designer of a project with a budget starting in the billions. Even if the title was strictly limited to the research and engineering scope. That kind of thing only happened in novels. The people who knew Ryan understood that he genuinely had the technical capability for the role. The public did not know that. The only publicly attributable accomplishments Ryan had were Scrapper and the brain-controlled prosthetic. And in Scrapper's case, the public had only ever seen the exterior armor shell. The internals had never been shown. A teenager. With that track record. Becoming the chief designer of a multi-billion-dollar project. In the public's eyes, he was nowhere near qualified. The moment the announcement went out, it would become international news. Possibly a scandal, because the story behind it would invite endless speculation. There was no way to keep it quiet. What worried the company more was Ryan's psychological state. Their prize asset was still so young. Would the outside pressure affect him? His life had been smooth from birth. Would public criticism damage him? How many psychologists would they need on standby? What kind of counseling would they need to arrange? 2. The possibilities had kept many people at the company awake at night, worrying about Ryan more than they worried about their own grandchildren. Patricia herself had been carrying the same anxiety. Ever since leadership had briefed her, her brow had stayed furrowed. Ryan, of course, knew exactly what Patricia was worried about. He turned the comforting around on her. What's there to worry about? Trolls are number one, no. They're just trolls. The harder they attack, the more swollen their faces get when the results come out. Besides, when they attack me, I don't lose anything. 1. Who did Patricia think she was talking to? In his previous life, Ryan had been the kind of person who fired a keyboard like an assault rifle. He'd been a troll among trolls. 2. And in this life, he had a system that converted attention, hostile attention very much included, into summon points. The trolls couldn't actually hurt him. Their hostility looped back around and fed his progress. Hate watching was still watching. Outrage was still attention. 1. It was, in a sense, the most nourishing poison available. Patricia watched him say all this with total ease. You'll need to hold on to that mindset. All the way through. She opened her mouth to say something more, then decided against it and changed the subject. Well. Since you're insisting, the project will obviously be approved. Preparations will begin within the week. The public announcement will be timed for some time after the new year. Ryan checked the date. The new year was only a few days away. Same arrangement as always. You handle the research and engineering. Everything else, you don't need to worry about. As she said this, Patricia sighed internally. She had a premonition. She was, in all likelihood, about to be promoted again. Fortunately, women had a lower probability of going bald. Ryan had no idea that Patricia's train of worry had run from his mental health all the way to her own hairline. He smiled. Then it's perfect. He cracked open the cola on the desk and poured himself a full, generous glass. Patricia rolled her eyes. Drinking that in winter is a fast track to an upset stomach. It's fine. He hiccuped. Building a new mech means building a new base, right? If you have any special requirements, tell me now. Otherwise we'll just go with the most efficient, fastest design. Also, you need to get outside and exercise more. You can't just stay shut in your room doing research all the time. You're still growing. You need to take care of your body. Patricia delivered an extended lecture, like somebody's mother, on the importance of exercise and healthy living, right there in Ryan's dorm room. She kept going until a subordinate called her phone and summoned her away. By that point, Ryan had happily worked through more than half the bottle of cola while watching the television series. The show that he hadn't been able to stand earlier had become significantly more watchable. The happiness didn't last long. Another visitor arrived at the dorm shortly after. It was Victor Thornton. At this hour, Thornton should have been at the plasma cannon facility. What brings you here? Ryan asked, a little surprised. He poured a glass of cola for the visitor. Thornton shook his head and declined the offer. No thanks. That stuff gives you an upset stomach. 1. The truth is, I came to say goodbye. I just received notice from leadership. Our project is being relocated inland. Oh. Ryan was more surprised by that. But he immediately worked out the reason behind it. The Crimson Typhoon project would be publicly announced soon. Once that happened, this entire region would be under 24-hour satellite surveillance. A highly classified program like the plasma cannon obviously couldn't stay here. All right. I can only wish your team smooth research going forward. Ryan said it with a touch of feeling. This was the first research team to separate from him. Thornton spoke with genuine sincerity. Thank you for everything. These past months have meant a lot. There's no need for thanks. We were all just helping each other out. Ryan said it as a courtesy, and Thornton understood it as one. He rubbed the back of his head. For a 40-year-old man of considerable height, the gesture made him look almost bashful. After thanking Ryan, Thornton left. The next morning, the entire plasma cannon research team relocated quietly. Ryan only learned it had happened when he got the update from Patricia after waking up. On the third day, the original plasma cannon workshop was completely dismantled in the span of a single day. The site was left without a trace of what had been there. The Crimson Typhoon's right arm wouldn't be getting a plasma cannon installed after all. Its destiny now lay in the mountains. Fortunately, Ryan had anticipated this. He'd made small modifications to the blueprints in advance. The Crimson Typhoon project wouldn't be delayed by the plasma cannon's departure. Preparations for the program were already underway at full speed. And while the project preparations ran their course, the new year arrived. Drawing manga/comic in Marvel. Chapter 116, New Year. The holiday spirit reached Dome Base. By the duty roster, part of the staff could go home for the break while the rest stayed to maintain the facility. Ryan, despite holding the highest security clearance on the base, was unambiguously in the group cleared to go home. He took the train. A few hours later, he was back home. His new home, to be precise. The family's old house had been on a busy street, traffic and foot traffic in constant motion, perpetually noisy. Tom had never liked it. The new place was somewhere quiet. Quiet enough that you could install 300 security cameras around the property and maintain round-the-clock, no blind spot surveillance of the perimeter without a single neighbor noticing or caring. Tom had also hired a few professional bodyguards. They stayed closed during the day. When Ryan arrived, he saw the bodyguards standing by in the living room. The members of his own security detail, who had traveled back with him, walked over and exchanged familiar greetings with Tom's bodyguards. Ryan made a face. They knew each other perfectly well. The whole standing at attention routine was theater. Lisa came in from the backyard and immediately spotted her son. "Let me look at you. How much have you grown?" She pulled Ryan over to a particular wall in the living room. Ryan looked at the height marks on the wall and sighed. "Mom. We moved into a whole new house. You recreated the height wall in the new house. Less talking. Stand up straight. There. 5'9". No idea how much taller you'll get." Ryan thought about Victor Thornton's height, a full head above everyone around him, conspicuous in any crowd. "Average height is fine," he said. "I don't need to be too tall." "Where's Dad?" Lisa rolled her eyes, withholding any warmth from the expression. "He's in his study on a conference call. Go find him yourself." Ryan stuck out his tongue. He knew his mother was still annoyed about the fact that he'd been the one who gave Tom the technology, the one who steered him onto the entrepreneurial path that had consumed the family's quiet life. He didn't dare ask where the study was. He'd just find it. It would double as a tour of the new house. The house wasn't lavish. A 3-story home, nothing extravagant. The one genuinely special feature was the backyard, which had a tasteful, landscaped quality to it. 3. The backyard had a small pond with a gazebo at its center. From inside the gazebo, you could see the fish in the water, both eating fish and ornamental fish, along with a few small turtles. Ryan couldn't identify the species. Zoology had never been one of his research areas. The study was a third-floor room facing the backyard. Turn your head and you could see the little pond. When Ryan walked in, Tom was still talking into his phone. He saw Ryan, pointed at the phone, and gestured for him to wait. "How's the business going on your end? Running into any problems?" Tom asked. Someone immediately translated his words into English. A moment later, someone answered. 2. We're installing prosthetics for around 4 to 6 customers a day. But they're all people from the same city or living nearby. Our after-sales network is very thin right now. A lot of people from other regions want our prosthetics, but they're worried about maintenance and repair access. I think we need to expand the service points as quickly as possible." The speaker on the other end had a heavy accent, one of the new international markets Triton 1 had recently entered. Tom listened and nodded along, offering a suggestion now and then. When the call ended, Ryan settled onto the study's sofa. "Dad. How's the suspension situation going over there?" "It's improving. Helios has backed off. I reached out to an old friend and had him work the situation from the inside. The deadlock is going to break soon. I'm also planning to bring him in as a shareholder in the international prosthetics subsidiary. We're doing business in a foreign market, and he's a local power player. If something like this happens again, we won't be caught as flat-footed as we were this time. Ryan didn't object. It was a minority stake in a foreign subsidiary, and a prosthetics subsidiary at that. Trading a piece of equity for local protection was standard practice. When you opened a business in a new place, you shared a bowl of soup with the local power players. The only thing that mattered was controlling the size of the bowl, and Ryan trusted Tom to handle that. The two of them talked, and the conversation drifted to the state of brain-computer interface research, domestic and international. You wouldn't believe this, Tom said. Before the suspension order, I heard Neuropath's investors were pulling out. I sent them a tentative acquisition inquiry, just testing the water. They actually replied. Told me they'd be glad to sit down and discuss it. Then the suspension order hit, and I didn't have the bandwidth to deal with them. Yesterday they called me, asking about the acquisition again. And here's the other thing. The moment Triton 1 launched, the whole brain-computer interface field reacted like a dragon had surged up the river. Countless small fish got flattened in the wake. There are surgical prosthetic labs trying to change their entire research direction, switching to our technology path. There have even been companies coming to us recently saying our Triton 1 security is excellent, asking whether we'd consider providing security system design. They want us to build encryption for their products. Tom recounted these recent developments, all of which were tied to his son, with the puffed-up satisfaction of a man who had had a couple of small drinks and reached a pleasant warmth. Ryan rubbed his chin and narrowed his eyes. Dad. This. Neuropath. What kind of company is that? Tom went quiet. Clack. You two. Come down. Dinner. Lisa had pushed the study door open. There was murder in her eyes and a spatula in her hand. Okay, okay. Father and son cut the conversation short and obediently followed her downstairs. The moment Ryan reached the dining room, he saw a heaping plate on the table. Cola braised chicken. Mom. Is Chloe coming over? Lisa set out bowls and chopsticks. You're back home. Of course she's coming over. 5. Speak of the devil. The words had barely left her when Chloe's bright, energetic voice rang out from beyond the front door. Mrs. Mercer, I'm here. Ryan went to open the door. Chloe stood outside in a goose yellow down jacket, both hands cupped in front of her mouth, blowing warm air into them. The wind had turned her face bright red with cold. Ryan. I'm here. Surprised. Surprised. Very surprised. He pulled her inside and shut the door behind her. That delivery was completely flat, Chloe complained, pouting. Wash up and come eat, Lisa's voice carried from the dining room. I made the things you like. 1. Thank you, Mrs. Mercer. Chloe pushed straight past Ryan, peeled off her down jacket, and bounded toward the dining room like a small deer. Ryan could only follow behind her. Drawing manga/comic in Marvel. Trust me and read first few chapters. Chapter 117, A Brain-Controlled Exoskeleton? 2. The four of them were still at the dinner table, Lisa smiling as she added more food to Chloe's bowl, when another knock came at the front door. Who is it this time? Before Ryan could get up, the household security staff had already gone to answer it. The visitor was a middle-aged man with a severe disability. All four limbs. He sat in a wheelchair, pushed in from behind by an attendant. Both of his arms were fitted with Triton 1 prosthetics, and he wore a sensor cap. He gripped the wheelchair's armrests and leaned forward, craning his head into the house with a mixture of urgency and anticipation, trying to see inside. The attendant behind him steadied his shoulders to prevent an accident. And this is... Ryan stepped out, taking a look. He didn't recognize the man at all. He glanced at his father, assuming this was someone Tom knew. Tom came out and smacked his own forehead. Look at my memory. I was in meetings all afternoon and completely forgot to tell my son about you. Ryan, this is Aaron Holt. You can call him Mr. Holt. He arranged with me earlier that he wanted to come meet you. Ryan glanced at Aaron Holt and had a fairly good idea of why he was here. Lisa looked at Chloe, who was sitting beside her with a bowl in one hand and a chicken drumstick in the other, blinking her big eyes and watching the unfolding scene with open interest. Lisa sighed. 1. You two, come back and finish dinner. And our guest, Please come sit and eat with us. Whatever the business is, we can discuss it after the meal. She went to the kitchen and brought out 2 more sets of bowls, chopsticks, and spoons. Once Lisa had spoken, Ryan and Tom obediently sat back down at the table. Ryan even added another drumstick to Chloe's bowl. Eat more. No more. I'm on a diet. Ryan looked at the 3 clean drumstick bones already on her side of the table and registered some doubt. And besides, no need. You don't gain weight anyway. Aaron Holt was wheeled to the edge of the table, smiling broadly. He apologized to everyone for the intrusion, then picked up a bowl and spoon and began to eat. This food is genuinely delicious, he said between bites, complimenting the cooking. Ryan observed him. Holt was clearly using a custom sensor cap, one that integrated the signal acquisition for both prosthetics into a single unit, capable of receiving and processing motor neuron signals from the left and right arms simultaneously. It wasn't a standard dual-arm prosthetic configuration, but the improvised setup didn't seem to limit him much. His eating motions looked close to a non-disabled person's. When the meal was finished, Ryan settled onto the living room sofa, and Holt finally explained why he'd come. 5 years ago, I was in a car accident. I'd built up some savings by then, fortunately, and I barely escaped from death's door. But as you can see, all 4 of my limbs had to be amputated. He used a prosthetic hand to tap the residual stump of one thigh. Over the past few years, I've followed the development of prosthetic technology closely. I even visited the Whitfield lab at Harvard. I was desperate with envy at what I saw there. I wanted to invest in them, just so I could have a prosthetic fitted on the spot. They wouldn't agree to it, so I came home and kept waiting. I'd been hoping that within 10 years I might be able to use one of their brain-controlled prosthetics. That would have been good enough for me. Then your company appeared out of nowhere and launched a brain-controlled prosthetic alongside them. He flexed the Triton 1 units on his arms. I've worn prosthetics from both companies. Yours is the better product. After I got the Triton 1 fitted, it took only a few days of training before I could eat a meal the way I used to. I still can't manage a fork properly. But eating food that I don't need someone else to feed me, that food tastes good. Aaron Holt laughed, his face full of satisfaction. Tom smiled at the side of the room, visibly pleased that his company's product had been able to help someone. However, Holt's smile contracted. You don't currently offer a lower limb prosthetic. And even if you did, for someone like me, missing all 4 limbs, fitting 4 separate prosthetics onto my body would not be an easy thing. He spread his hands and produced a large, rueful smile. So you'd like our company to develop a brain-controlled prosthetic specifically designed to be practical for you? Ryan said, stating Holt's purpose for him. Holt nodded. Yes. That's exactly my thinking. Ideally, the prosthetic should be able to support my normal daily mobility. And of course, this wouldn't be without compensation. Holt leaned his body forward from the wheelchair. The attendant behind him quickly steadied him. For that prosthetic, I'm prepared to fund your company with at least $600 million in research budget. Pure funding. No expectation of any return on investment. I have only one condition. Holt extended a prosthetic hand and held up 6 fingers. 3. When the prosthetic is finished, I get to be the first person fitted with it. And during the testing process, I can serve as your volunteer. As long as there's no risk to my life. Ryan had never encountered a person like this before. Someone who arrived carrying his own research grant. He thought about Holt's request. By Holt's own description, the device being asked for warranted a different name. A brain-controlled exoskeleton. Holt's eyes were full of anticipation, nearly bloodshot, fixed intently on Ryan, as though terrified Ryan would shake his head in the next second. After thinking it over, Ryan nodded. The research is feasible. You can work out the specific terms of the collaboration with my father. However, the single word made Holt, a man worth well over $1 billion, tense up immediately. I can't give you a timeline right now. I have other, more important projects on my plate. Your project is not high priority. Ryan laid it out bluntly. Holt exhaled. As long as Ryan wasn't backing out. That's fine. I've waited several years. I can wait 10 more. Thank you. Truly. I know this is a lot of trouble. If Holt had been able to stand, he would have bowed to Ryan right there. His confidence in Ryan was complete. The source of that confidence was the Triton 1 he was currently wearing. He believed that Ryan would, one day, develop the prosthetic he imagined, the one that would let him move freely again. With the matter settled, Holt didn't linger. He arranged with Tom to discuss the details after the new year and left in a state of genuine happiness. Tom then brought up another topic. Next month, the country is hosting the Winter Paralympics. I fitted the arm disability athletes on our national team with Triton 1 units. A sponsorship, essentially. Unfortunately, the events are all winter sports, ice and snow. Not the best showcase for our prosthetic. If it were the Summer Paralympics, that would be perfect. It would cause a sensation. Ryan thought about it. A person fitted with a Triton 1, playing table tennis, against an opponent in a wheelchair or with a single arm. The match would be decided before it began. He had a sudden, uneasy thought. Were Prism Science's prosthetics going to end up banned from the Paralympics? 1. Drawing manga/comic in Marvel. Trust me and read first few chapters. Chapter 118, Preparations in full swing. The New Year holiday passed quickly. Ryan rested well throughout the break, occasionally getting Lisa to make a few chicken drumsticks to feed a certain perpetually dieting young woman. By the time he returned to Dome Base, his mental state had visibly improved. Patricia's complexion had not improved comparably. The base had returned to normal operations. The research teams were proceeding with their work in orderly fashion. Patricia was also proceeding with her work. When Ryan saw her again, she was at her desk on a phone call, her computer screen filled top to bottom with a to-do list. The administrative office outside her private office was even busier. People were working at computers everywhere, the atmosphere thick with urgency. The dense clatter of keyboards made the place sound less like a research facility and more like an internet cafe at peak hours. The base was deep in the early stage preparations for the Crimson Typhoon project, and the first thing in the firing line was administrative coordination. When she saw Ryan, Patricia's mouth didn't pause for even a second. While still talking to whoever was on the phone, she pulled a stack of documents from a drawer and handed them over, gesturing for him to read. Ryan took the stack and looked. It was a public project announcement document. The opening line was the project name. Crimson Typhoon Project, a 7,000-meter class crewed deep submergence heavy underwater operations mech. There was no question about it. The name Ryan had originally proposed, the aggressively named Hunter Program, had been retired. Given the scale of what the country was about to do, suddenly beginning construction on a 70-meter combat mech, keeping the project named Hunter Program would have kept the leadership of several other nations awake at night. Changing the name was the equivalent of putting on a thin disguise. At least it provided a surface-level justification that was defensible in public. 1. As for the obvious problem that building a 70-meter mech for deep-sea work made no sense at all, a justification that held up on the surface was enough. The moment you genuinely worried about whether it was reasonable or not, you'd already lost. Ryan kept reading. Next was a public-facing project introduction. His name appeared in the chief designer column, alone, in a tier by itself. The document also introduced the project's participating organizations. The National Oceanic Mineral Resources Research and Development Association. The Marine Heavy Industries 911 Research Institute. The National Academy of Sciences Institute of Automation. The National Academy of Sciences Institute of Acoustics. More than 200 related institutions and units in total. It did have a certain deep submergence research flavor to it. The project's projected budget was $35 billion. Considerably more than the $20 billion Ryan had originally requested. Presumably leadership was worried about him going over budget. As for the project's stated purpose, the document read, to construct a new class of deep submergence equipment, to seek expanded possibilities for deep-sea resource exploration, to serve as a comprehensive review of the nation's overall industrial strength and engineering capability, to test the nation's capacity for innovation and scientific research, and, through the project's associated research, to advance progress across the nation's materials science fields and to accelerate industrial development in specialty materials such as titanium alloys. Strip away the official phrasing at the front, and the rest was easy to understand. Building Crimson Typhoon would take more than the technology alone. The system had given Ryan the blueprints for Crimson Typhoon. It had not told him how to actually get Crimson Typhoon built. The simplest version of the problem, constructing a mech like this required what kind of industrial machinery? What kind of facility? How many engineers and technicians? When fabricating the mech body, did you build the arms first, or the legs? Or the internal engines first? After completion, what maintenance approach was optimal? One question after another, all of them engineering problems. The system, which only provided technology, would not lift a finger to also provide an engineering plan. Solving those problems depended on the coordination between massive industrial capacity and engineering construction capability. Beyond that, the demand for various materials and technologies generated by the mech's construction would feed back into the broader industrial base. The project would push a portion of the country's companies to upgrade their own technology and production capabilities to match the project's requirements. The domestic titanium alloy industry, for example. The country had long lacked competitiveness in high-end titanium alloy on the international market. The titanium alloys used in petrochemicals, aerospace, and marine engineering were almost entirely imported. The titanium alloy armor on Crimson Typhoon was, without question, a new alloy class. Producing it would require steering a number of companies through structural upgrades. So Crimson Typhoon really was a thin disguise stretched over a surface. Behind the project, hidden underneath it, were numerous industrial development programs. The investment in those programs might exceed the cost of Crimson Typhoon itself. But matters involving industrial structure adjustment had nothing to do with Ryan. He didn't need to think about any of it. The civilian patents for the new materials and new technologies belonged to him. If they could be produced for civilian applications, he could collect the royalties while lying down. By the time Ryan finished reading the document, Patricia had finally finished her phone call and carved out a sliver of free time. She opened a rendering on her computer. This is the latest design. Take a look. She stepped back from the desk and moved to the side to stretch her stiffened body. Ryan looked at the rendering on the screen. Like the current dome base, it was a steel structure facility. Steel structure construction was fast and easy and left generous interior space, which suited a mech facility's spatial requirements. The facility in the rendering stood 100 meters tall. The walls sloped slightly inward toward the center, the overall shape approaching a cone, though the top was left as a large flat surface. On the facility's surface was a massive retractable door. It stood 84 meters tall. Even from the rendering alone, the scale of it was palpable. Ryan studied the rendering and thought for a moment. Can the dome up top be changed? Changed how? Patricia turned back toward the screen. Change the big flat top into an opening that can open and close. Hey! Turn it into an exit. Patricia looked at the spot Ryan was pointing to, assuming he'd indicated the wrong place. You're sure it's the dome at the very top that you want to open into an exit? Ryan nodded with absolute certainty. There's not much point in opening an exit there, is there? Ryan rubbed his chin. Maybe there's no point now. But who's to say there won't be a point later? The aircraft capable of carrying a mech didn't exist yet. But what if, someday, one did? Patricia didn't follow his reasoning at all. She also didn't find it strange. Ryan's ideas were routinely beyond ordinary comprehension. She nodded and agreed. Understood. I'll pass the change along to the design team. Any other requirements for this exit? Just make sure the opening is large enough for Crimson Typhoon to come out through it. All right. Patricia was now absolutely certain of one thing, she was an ordinary person. Fine. I'll explain it to the design team. Thanks, Patricia. Drawing manga/comic in Marvel. Chapter 119, The Third Project That Can't Be Copied. Ryan left Patricia's office and went to Storm Bay, where the three triplet sets were still running connection training. None of them had gone home for the new year. Frank Cabrera and the rest of his team had stayed too, keeping the pilots company. Happy New Year! The holiday atmosphere hadn't fully dissipated. When Ryan walked in, Cabrera's group of researchers and the pilots waiting their turn on the bench all greeted him with smiles. One of them even produced a small holiday envelope and held it out, leaving Ryan caught between laughing and exasperation. This is basically a bribe. He took it anyway. After exchanging holiday well wishes with everyone, Ryan started getting Cabrera's team to brief him on the experiment progress over the break. Things are going well. Our best performer can now maintain a stable connection with the storm arm for 2 hours, Cabrera said. That settled Ryan's mind. He'd predicted the connection wouldn't be a difficult problem, but he'd still harbored some worry that the three triplet sets might fail to adapt. He talked with the triplets next and learned that they hadn't only been adapting to the arm connection over the break. They'd kept up their three-person sync training too. After a long period of adaptation, their three-person sync duration had stabilized at over 3 hours. Ryan ran the numbers. If they could maintain that duration inside an actual cockpit, they'd already meet the standard for live mech operation. The probability of that was low, though. Inside the cockpit, the baseline 3-person sync load plus the additional load of an entire Jaeger would inevitably reduce their connection time. 1. Keep it up. You've worked hard these past months. Ryan clapped them on the shoulders and left Storm Bay. Like a lord surveying his territory, he made his way to the firefighting mech bay next. This time he didn't see Kyle or Marsh in the bay, only a few technicians. After getting an update on the firefighting mech's progress, Ryan left and headed upstairs to the drift lab to check on recent developments there as well. Marsh was currently leading a team to revise the firefighting mech's design, working to incorporate all the suggestions Ryan had made into the new specifications. Reeves and his group were doing what they always did, collecting drift data and analyzing it. That project had entered a plateau. The goals Ryan had originally set were now met, and the data analysis was more than thorough. Ryan had finished reading every analysis report Reeves submitted, and he'd fully mastered the liquid neural connection technology. By rights, the project could be wound down, because Ryan had no immediate plans to pursue deeper research in that area. Reeves and his team disagreed. They believed the project still had unexplored territory. For instance, beyond the sync fluid media Ryan had specified, were there other viable media? What effects did the sync process have on the human brain and psychology over time? Reeves's group had established several research directions and were now working toward them. Ryan could only wish them luck. The following days were ordinary base routine. He helped out at the firefighting mech bay when he had time, or checked on the experiments in Storm Bay. Otherwise he went outside to exercise, or confirmed the Crimson Typhoon preparation progress with Patricia. Oh, and there was the system's third project. The progress had climbed to 13% over this period. 1. The first batch of documentation had been released. It was a project that made his scalp prickle just looking at it. Ryan opened the system panel, looked at the dense blocks of code displayed there, and immediately felt himself developing reading comprehension issues and a phobia of densely packed objects. The reason was simple. The third project was, of all things, Moss. 8. The artificial intelligence from a science fiction film he'd seen in his previous life. Moss controlled global network resources. Operating through a space station, it could perform communication relay, data transfer and storage, real-time language translation, logical computation, and a long list of other functions. Put simply, any device anywhere in the world, as long as it was connected to a network, Moss could influence or manipulate it. Backed by enormous server resources, Moss had built a vast database of human civilization, paired with extreme computational speed, capable of simultaneously processing every request from both the ground and the space station. Whether Moss met the standard of a self-aware strong artificial intelligence, Ryan couldn't say. But its capabilities had been displayed in full in the film. At its most expansive, it could provide simultaneous translation for every person on the planet, eliminating communication barriers. At its most reduced, it could take a space station and set off alone on a path of escape. However, that was an awful lot of code. Ryan looked at the code displayed on the system panel and felt his head swell. The base architecture of Moss alone ran to a line count measured in the billions. Never mind the databases it might contain further down, the databases capable of reconstructing human civilization. This one genuinely could not be copied. The system didn't provide a real-world data transfer service. Even if Ryan tried to copy the code by hand, typing without stopping for a single moment, the base architecture alone would take him several years to transcribe. Never mind the other functional modules that came after it. The communication and computation functions, each with code more voluminous than the last. Even typing at the speed of a Gatling gun, he wouldn't finish transcribing this code in his lifetime. Since acquiring the system, this was the first project he couldn't simply copy. Still, while the code couldn't be transcribed wholesale, he could study the concepts and algorithms inside it. Those were the technology's true treasure vault. If he understood the concepts and the algorithms, he might be able to create an artificial intelligence on the same level as Moss. The databases and the functional modules could be accumulated gradually once the core AI existed. 2. So Ryan's research focus over this period became the system's decrypted base architecture, along with a particular artificial neural network algorithm. A neural network algorithm was a model that simulated the structure of the human brain. It was composed of many layers of different units, each unit comparable to a neuron in the human brain. These units were functionally and structurally simple, but like the neurons in a brain, they were interconnected. Each unit's computational result on a piece of data fed into the next layer of units. Computing layer by layer in this way, the network could ultimately perform extraordinarily complex calculations and arrive at the result people wanted. Neural network algorithms had wide applications. Image recognition, speech recognition, and even AI face swapping all had a neural network's shadow behind them. It was also the basis for a computer's ability to learn on its own. Take image recognition as an example. If you showed a computer a picture of a cat, the computer could use the algorithm to analyze and remember the cat's features. Then, in other pictures shown to it later, the computer could identify the cat in the image based on those features, and the identification would grow more accurate as the volume of identifications increased. That was machine learning. Drawing manga/comic in Marvel. Chapter 120, The Public Announcement. The algorithm was only one important component of an artificial intelligence. The other components remained to be developed through the system. This was a rare project with a low barrier to entry. Truly reconstructing an AI on the level of Moss would require terrifying resources, far more terrifying than Crimson Typhoon. But if Ryan lowered his sights a little, he found that the algorithms and architecture inside didn't carry that many constraints. The artificial neural network algorithm, for instance, could run on the computer in Ryan's dorm room as it currently was. Or, with a computer that had a graphics card optimized for parallel computation, it would run just as well. Ryan had experimented on his own dorm computer. The algorithm the system provided was, in functional terms, considerably more powerful than every algorithm he'd encountered before. It was far more capable than even the assistive operating AI inside Crimson Typhoon. That day, Ryan had just returned from a morning run, taken on Patricia's recommendation. He wiped the thin film of sweat from his forehead and was about to take a shower, then continue training the artificial neural network on his computer, which was to say, letting it study. The phone in his pocket rang. He turned on the air conditioning, stood beneath the vent, and answered the call. "Hello." Patricia's voice came through. "Are you in your dorm right now?" "I am. Just got back from exercising, about to shower." "Do you need to come by, Patricia?" "Then never mind. It's nothing major. I just wanted to let you know that the project's basic information is going to be posted on the Department of Science and Technology's official website shortly. Our media partners will guide the coverage at the appropriate time." "Understood." Ryan's tone was unbothered. He'd been tracking the project preparations and had guessed the announcement would come within these few days. Patricia sighed. If this project weren't so large and so hard to conceal, keeping it unannounced might honestly have been the better option. The company's leadership had also considered executing the Crimson Typhoon project in secret, but had ultimately abandoned the idea. The 100-meter facility alone couldn't be hidden, let alone the large number of personnel who'd be moving into the base afterward. If the media, foreign media in particular, dug up the story first, the country would be put on the defensive internationally. Better to lay all the cards on the table from the start and seize the initiative in shaping public opinion. Ryan laughed. It's good that the project's being announced. On the other end, Patricia rolled her eyes and didn't know what to say. That's all. I've told you the news. Go take your shower. Hanging up. Okay. Talk later. Ryan tossed the phone onto the bed and went into the bathroom humming a tune. And at that moment, exactly as Patricia had said, the Crimson Typhoon project announcement had just been posted on the Department of Science and Technology's official website. Less than an hour passed before sharp-eyed people noticed it. A new 7,000-meter class deep submergence project? Wasn't this already completed? On a city bus, a research industry worker named Sean was on his way to work. Sipping coffee, he pulled out his phone partway through the commute to check the department's website for some policy information. He noticed that the major projects announcement section showed an update. He clicked in and found, of all things, another deep submergence project. Did the website glitch? That seems unlikely. Curiosity piqued, Sean opened the project listing. The first thing he saw was the project's full name. Crimson Typhoon Project, a 7,000-meter class crewed deep submergence heavy underwater operations mech. He nearly spat out the coffee in his mouth. What? Did I read that right? A mech. Sean muttered to himself, rubbed his eyes, and looked at the title again, confirming that he hadn't misread a single word and hadn't misunderstood the meaning. Reading further, the project was exactly what the title said. The goal was to construct a large mech capable of operating at depths of 7,000 meters, while also driving the development of the country's upstream industries during the construction process. And how large was this mech? 250 feet. 1,700 tons. 1. Just laying those two numbers out was enough to make a crowd of people's eyes fall out of their heads. Sean got off comparatively easy. Only his glasses fell off. Are they insane? Can a mech like this actually be built? It's several times the size of Scrapper. What he didn't anticipate was that the more surreal part was still ahead. When he saw the project's chief designer, the coffee he hadn't yet swallowed could no longer be contained. He sprayed it directly onto the bus floor. 1. He bent down to grab a tissue and wipe it up, while the photo he'd just seen surfaced involuntarily in his mind. Ryan Mercer. Putting a 15-year-old in charge of a project this large, as chief designer? Had the world gone insane? At the same time, the country's major media outlets began reporting on the new project. Today, the nation publicly announced a major scientific research project related to deep-sea exploration. The project ingeniously integrates with the mech technology that has recently drawn widespread attention. It is expected to construct a large mech standing 250 feet tall, weighing 1,700 tons, capable of operating in deep waters at depths of 7,000 meters. The mech is named Crimson Typhoon. Its construction will employ a large quantity of advanced materials and advanced technologies, providing powerful momentum for the progress and development of the nation's related industries. Building a mech of this kind will also be an enormous test of the nation's industrial system and engineering capability. The project could not be concealed, and it was destined to generate enormous attention. So the major outlets came out with all guns blazing. Their project introductions focused on the market demand Crimson Typhoon would generate and the way policy adjustments would drive numerous upstream industries. Or else they promoted it as a test of the country's industrial strength and engineering capability, with the framing that once the mech was built, it would elevate the nation's industrial strength and engineering construction capacity. In short, every report did its best to downplay Ryan's role in the project. Also downplayed was the project's budget. Unlike the announcement document Ryan had seen earlier, none of the reports or public listings mentioned the budget figure. They all glossed over it with careful, evasive phrasing. Under the major outlets' efforts, the Crimson Typhoon project quickly entered the public's field of view. Countless people, like Sean, had their glasses knocked off by it. Did I read that right? Did they forget the decimal point on this mech's dimensions? This project has the mech expert as chief designer? He's still just a teenager. I know mechs are his area, but is this really appropriate? A mech that operates 7,000 meters underwater. That immediately sounds like nonsense. If you'd said a mech that flies 7,000 meters into the sky, I'd find it slightly more believable. 2. I genuinely cannot understand this project. This feels way too surreal. I can't find the budget figure anywhere, but for a major project posted on the Department of Science and Technology's official website, and a mech that big, the budget has to start in the billions. 4. Pouring that much money onto a teenager and letting him build something with no clear purpose, is that really a good idea? Do people know how many people in this country are still struggling to get by? The online comments quickly reflected the public's doubts about the project. There were a lot of clever people these days. Evasive phrasing had little room to survive. Many people had seen straight to the heart of the problem.
Additionally, if you would like to request novels and access my Google Drive where I have 200+ audiobooks, then you can join my Patreon. Link is also provided in the description.